as a 3-tier architecture. Once the input is received in the middle layer in Express.js, it will be processed in the MongoDB. Accordingly, the output is taken from MongoDB. It will be sent to the user who is working in the front end. Here in the development team itself, we have got 3 set of teams. One team is doing UI UX design or front end coding. Another team is doing API development management and hosting. The third team is about database management. Nowadays, students of engineering colleges should learn all these 3 stacks of software. Here, this is what is called as full stack software development. Or if it is web application development, we can say that it is full stack web application development. If you are dealing with a Windows-based application, it is what is called a full stack Windows application-based development, or full stack Java development, or full stack Python development. Here, a developer develops front end, middle end, back end by himself. At least, maybe he is working with UI UX design. He should have knowledge about the middle end and also the back end. This is what is the present scenario. But in the future, it is not if. The question is only when. When means the whole application development would be done only in the cloud itself. Here, usually people develop application in their development environment. Here the development environment may be in TCS or Infosys or Tech Mahindra, mean the computers which are provided by Tech Mahindra company, or the computers which represent the development environment in the cloud itself. Once the development environment does the development, the whole code would be moved to the testing phase, where the quality analyst specialists will use manual testing approach or automated testing approach to do the necessary testing, which the testing cases would have already been derived from the SRS specification done by software requirement engineers. Once the testing is done, the application would be moved to production. So in the production, the application would be hosted in an on-premises server. When we talk about 1980s and 1990s, TCS company had an on-premises server. Infosys company had an on-premises server for each and every client. And IBM company had an on-premises server for every client. Or the on-premises server can be, if we talk about a client called Colruyt, he's a Belgium client. We can also talk about Bank of Shanghai. It is in China. The on-premises server can be located right inside China itself, nearer to the Bank of Shanghai, where the application is hosted. Once the application is hosted, it is the responsibility of the production team to manage the application with regard to any configuration issues or any technical issues, any network issues, any security issues. Everything, once the application is moved to the production environment, it is the responsibility of the production team. The production team is also called as support team or 24/7 support team, who always responds to the calls received from users, end users. Here we have seen the 3 set of teams: development team, who does the full stack web application development; testing team, who does the test for that particular application; and the production team, which manages the developed application in the environment where the application can better scale and be available always to end users' requirements. Now, this is the diagram which will clearly tell you the development environment gives the input or gives the output to test environment. Test environment will give its feedback to development environment to fix the issues. Once the testing is done, it would be the developer code would be moved to production environment. Yes, sir. Yeah. It's only now I am changing, sir. Yes, sir. If there are any issues, kindly let me know immediately, sir. Yes, sir. Here, Balaji sir has touched upon the topic DevOps for cloud native development. The need for this FDP lies in the issues with regard to development, the issues in the testing, the issues in production. See, as we all know, a client will give requirements to the requirements engineers. So based on the requirements only, application development team will develop code based on the design. testing team would do test cases based on the SRS specification, and production team would do the production hosting based on client's requirements. Here, the DevOps is a technology which talks about the issues faced by or faced between development team, testing team, and production team with regard to platform issues, with regard to platform specific or configuration specific items. Platform specific items, like, for example, I have developed an application in Node.js with the latest version. I have used Express.js for API development with the latest version. Also, I have hosted it in a particular web application host server. Maybe it is like Engine server or any readily available web application server. The testing can be done with the help of Node.js framework in the development team in a single system. In the environment where the application is developed, maybe the application is running very well. When the application is moved to the quality analyst team, the quality analyst team would get the same output only if they use the same configuration settings, like the build which the Node.js being used by development team, Express.js version used by development team, and all the configuration settings should be needed by the QA team as it was used in the application development. Also in the production environment, the same configuration settings used by application team and testing team should be used. It's only then the production team will get only production issues. Otherwise, production team will always get only configuration-based issues. Here, DevOps is the topic of this FDP. DevOps is the technology which seamlessly moves. Seamlessly means without any issues. Transparently, it seamlessly and also quickly moves the software development from application development to testing environment and to production environment without any configuration issues. There can be issues with related to business development or business requirements specification or software requirement specification. DevOps is the workflow or the approach which removes the configuration related issues from the software development between application team, testing team, and the production team. Here, as we are students and software developers, we will see, when you are a student, you think that after the completion of a degree, you will go on code in the software company. Also, software engineers, newly joined software engineers who are doing the actual code, full stack development, or Windows-based application development, or maybe they are doing embedded application development. They all think that they are the only people who are doing all the kinds of works. But in reality, we can see that there are people in the software companies. Those people are what are called as IT operations specialists. They are the team who takes care of the application during production. Production means once the application is hosted in the production site. They are the one who waits 24/7. They are what are called as the support teams. They are always looking for any issues in the application while the application is being run. They will maintain the version. If an application has an error, they will quickly roll back to the previous version where the application was performing very well. They are the people who are looking for any issues which relates to scalability. For example, during Christmas times in European countries, they don't move any kinds of new production into their application, because if there comes if they get any issue in production, the total business would be lost. In that case, that is in December and January, European companies need support only from production team, because at those times they cannot predict how many users will be using their application. If the number of users increase, their sales will be increased. So they will not do any kind of new software development, but they always look for new users using their application. When new users use their application, scalability of the application should be performing very well. Scalability here refers to the performance of primary memory, performance of CPU, performance of network, and performance of all the hardware with regard to number of users accessing the application. Also availability. Availability is a feature which refers to when the system goes down, Is there any other option so that the application is always live to the clients? So if the primary hardware fails, the secondary hardware should be available. And also in the same production server, multiple applications of the same project or for different projects. For example, in the same project, when I was working in a project, I was working in admin team. In the same project, sales team was also there. In the same team, inventory project was also there. So in the same production server, for the same project, we will have smaller projects, smaller sub-projects would be running. In each and every project, there will be folders, there will be files, there will be resources like volumes, there will be resources like programs. Each and every resource of this kind should not conflict with one another. Here, for each project, the separate segregation of resources should be made. This is done by IT operations team. And if there comes any security breach, it should be monitored by IT operations team. And they are the ones who provide storage from network attached storage or storage area network to the end users. Because not all data which we use come from a single storage medium. Many of the times we use multiple systems in the production environment. When multiple systems are using the same network medium, the network medium becomes a shared medium. In that case, we refer to the particular shared medium as network file storage medium or network attached storage medium or storage attached network medium, depending on the application in which we are used. These are the things which an IT operations would do: hosting, support, version maintenance, scalability, availability, namespaces. These are the things which are very important in the viewpoint of clients. Here, this diagram will clearly tell you what actually the basic work of IT operations process team do. Run the applications which it has received from testing team. Actually, the application is built by application development team. Then it was tested by quality analyst team. Then it has been moved to the production team, where the production team runs the application in the production environment. It maintains the infrastructure with respect to availability, scalability, and all the things. And also it does local private network facility for multiple nodes working in the system and also for multiple storage area networks. Then it provides security. It also does 24/7 support or weekly support or monthly support based on the agreement which they have made between the client. The problem solving. If there comes any problem, the end user will raise the issue as a ticket. The ticket would be taken up by the 24/7 support team in the production team. They would address the issue or they would escalate it to senior managers in the IT operations. Am I audible, sir? Yeah. So here comes the concept of cloud native development. DevOps for cloud native development. Here, cloud native development means the application which we are making up in the application development, and testing which we do in the testing environment, and production we do in the production environment. Everything should be related to cloud native development, because when we develop an application, it would perform very well in the development environment. But in the production environment, because millions and millions of users are trying to utilize web-based applications and mobile-based applications, we cannot predict the availability and the scalability, security, and other issues. For this purpose, also when an application is being used, when an application is developed in Windows environment, we don't know whether it would perform the same in the Linux environment, in the Mac environment. The solution for all these hardware-related issues, software-related issues, is using cloud-native development. If you develop your application in any development environment, maybe it is in Windows or Linux or Mac or any other operating system, if you are able to use cloud storage or cloud platform, then you need not bother about the environment in which the application has been developed. So you need not bother about. So in 2010s, the idea of software systems running on premises was moved from on premises to cloud. Here, along with the cloud native development, another kind of development approach came into effect in 2010s. Actually, in software development lifecycle model, we know there are two basic lifecycle models. One is waterfall lifecycle model, and another one is spiral life cycle model. In waterfall life cycle model, each and every stage would be completely done, then it will be moved to the next stage. In spiral model, the requirement can come at any time. Here, we have got another model, which is what is called as, apart from spiral model, we have got another model, which is what is called as agile model. And by lately, we call it as Scrum-based application development model. In agile model, we get input from the client. Immediate for the input, we directly go with application development and testing and production moment. Then whenever the requirements come, we immediately go for its development. We do testing for it. Like that, it is what is called as agile based approach. Here, when we talk about cloud native development, we have got another kind of software development approach in practice. This kind of approach is what is called as microservices based application development approach. What is meant by microservices based approach? Assume you have a project in which you are developing a web based application. When you are developing a web based application, users will have different number of front end web pages. For each and every different web page, we may use different API to respond to that particular request from the user. Each API in our development approach can be considered as a separate microservice. We all know that API is application programming interface. This API can also be technically called as a service. Now we are talking about an approach called microservices based approach. In microservices based approach, one or more APIs are considered as a microservice. Actually, for this web application, login, user profile, inventory, search, orders, payments, shipping, all these are considered as the single application. But if we consider login and user profile alone, then we can say that login, user profile alone as a microservice. Then with regard to inventory, you can go for inventory, search the inventory. This is another microservice. Orders, you can take that as a different microservice, only depending on your application development scenario. Payments can be taken as another microservice, or payments and shipping together can be taken as another microservice. Here, the point is, the software development team does not need to, the software development team need not develop the whole application. Instead, the software development team can develop first only two services like login and user profile. Then it can hand over this microservices to testing team. Once the login user profile is done by testing team, it can move it to production. So, meanwhile, testing team would be working with inventory and search APIs, and at the same time, development team would be working with orders, payment, and shipping. Here, all the teams like application development team, QA team, and the production team are all working with different sets of APIs. This approach is possible only if the application is developed in terms of microservices based approach. Here, when we talk about microservices based approach, we can combine the workflow models or integration model like DevOps. Here, development, it refers to development operations. But here, the DevOps is a kind of process model. DevOps is not about any kind of technology. It is a model through which we can integrate application development, QA, and production environment, so that the movement of one set of microservices would be seamless from application to testing and to production. Here, when different sets of microkernels are being developed, all the teams would be actively engaged in different part of its microservice management. Here, we can say that DevOps differs from IT Ops in this way. It integrates software development and the IT operations. Actually, IT operations team would work only with production. But here, DevOps is an approach which integrates software development and IT Ops. I will tell you how does it integrate. Here, the application is broken down into microservices, and the continuous seamless movement of application from application to production is being monitored. We will see how it is being monitored using DevOps approach. Here, the advantage of using DevOps approach is quicker software development, because when we develop the whole application, when it is moved to QA, they will take a lot of time. Then when it is moved to production, they will take a lot of time. When the production team finds a number of faults, the application team would scold QA team would scold production team. They will, it will become a cycle of conflicts. But if we are using a microservice based approach, each and every service is crossing application development production environment, and we are adding one more service to the existing production moment. So it gives error-free, quick software development approach. Also, because we are using DevOps based approach, we are the application development is free from major configuration based approaches. Let us see how configuration based issues are resolved in DevOps approach. This is the diagram, infinity diagram, which will clearly tell you how configuration issues in DevOps is resolved. As we are aware of the software development life cycle, here also we see about the first step plan, then we go for plan, refers to design, then we go for code, and once the code is done, we are building it, then the build is sent to test, then it is released and managed, deployed it into the production environment, then it is operated by the clients. But they are monitoring, the IT operations team is monitoring for any kind of issues which the clients are reporting to them. Once any issue is received, here this infinity refers to not the whole software deployment. This infinity refers to the first set of microkernel services: planned, code, build, test, release, deployed. Then when the first set of applications is in deployment, the second set of microservices are in planning and code, and they are in different stages. This is how this infinite diagram should be understood. Here in DevOps based approach, all the teams are actively working. So this diagram also will clearly tell you development team is working with the QA team is working with IT operations team. Sometimes development team would have developed something, it would give the code to QA team where it overlaps. Sometimes QA team would be moving something, some code to IT operations. It is the combined diagram would tell you that. At sometimes when there are technical issues, all the teams would have to work. So the center DevOps shared diagram tells you that. See here, if we want to understand what is DevOps based approach, we have got to discuss the basics of virtualization. We all know that virtualization is a method through which a single hardware is virtualized as different segments of hardware to different operating systems. Let me come directly to the point. OS level virtualization is a kind of virtualization in which a single operating system shares the hardware resources like primary memory, CPU, storage, that is the secondary memory, network, and all the hardware to the running two different applications running on top of it. Each application thinks that it is using a hardware which is the full hardware, but it is not so. Each and every application will have a separate set of dedicated hardwares allocated by the OS. Actually, we have got virtualization in different levels. Let's have an example. The idea of DevOps may be introduced in 2013, but its precursor has existed right in 1980s when Linux was developed. Actually, when Linux was developed, the Linus Torvalds used chroot operation to go to another root user in the same operating system, because when he was making different updates, he wanted not to interpret or interrupt the existing operating system. So he used a separate container or separate part of CPU, primary memory, and the storage, which he referred to as jail. Here jail refers to a part of hardware which ran the new update of the Linux operating system. When this jail is running on the particular Linux operating system, we can say that two Linux operating systems were running on the same machine. Similarly, Solaris containers were able to run on the same Solaris operating system. The Solaris operating system was able to run multiple applications on top of the same Solaris OS. It was developed by Sun Microsystems. We all know KVM. These two operating systems we might have seen, we might not have seen, but in our laboratory experiments, we might have come across KVM. We all know that we can install Ubuntu on a bare hardware Then on top of Ubuntu, we can install KVM, kernel virtual machine. Once KVM is installed, we can install any guest operating system on top of it. Once any guest operating system is installed, we can run multiple operating systems. Here, KVM acts like an operating system, which allows multiple operating systems to be installed on top of it. Here, KVM can be considered as a para-virtualization based approach. Here, in these previous significant cases, we have seen that virtualization was used to run multiple applications on the same operating system. But in 2013, people started a company called Docker Incorporated, where they ran 3 applications with the same configurations, but the 3 different applications were used, but the 3 same applications were used by 3 different teams. This is the idea. Previously, 3 different applications were running on the same operating system. Now, same application with 3 different replicas were running on the same system. The first replica was used by application team. The second replica was used by QA team. The third replica was used by production team. Why do we need to replicate a single application into 3? Because the issue majorly faced by application team, QA team, and production team is this. They face 80% of problems in terms of configuration definition. Only 20% of issues only they are facing in terms of business requirements or technical issues. So, in order to resolve configuration-based issues, application team, when it has finished application, it creates an image of the application. Here, the image consists of the application along with its configuration information. For example, let us assume that I am developing a web application using Java, JDK 8.5. Now, I have completed my application development. When I create an image, the image would consist of the application along with JDK 8.5 as well. If the application is built, the image would be this. The image would consist only of binaries. Here in this case, the binary consists of class files. Where it is run, it would be converted to machine language using GRE. Here the image consists of the application's binary, the configuration information, JDK. If the JDK depends on any other binaries, it dependencies would also exist in the same image. Now, if the image is to be run by another team, like a QA team, now another container would be run on top of the same machine. Application development team is working on first the container. Now the QA team is working on another container, which is a replica of the previous one. Now the QA team need not do any kind of configuration settings. They are working with the same configuration setting, but they are doing the QA work. Once the QA is done, we can go for creating the third replica or second replica in which production team would work. Here, Docker is an idea in which a same application will have 3 replicas, but each replica would be worked upon by application team or QA team or production team. This is what the idea of Docker is about. Here, Docker can be considered as a platform as a service product. It was invented in 2013 to seamlessly move an application from application development to testing environment and to production environment. Is the screen visible, sir? Is there any issue? Can I continue? Yeah. So now we understand what DevOps actually means. Now DevOps is a technology or is a workflow or a process through which application team does not give the code to QA team or does not give only the code to the QA team. In DevOps based approach or DevOps based workflow, application team hands over the application code, its built binary, that means the application's binary code, its dependencies, its configuration settings, all together as a single image to the team. So this is how DevOps is made up of. Here, DevOps works alongside with the cloud native development. Instead of making up your application with respect to an on-premises or one hardware supporting application, it's better always to use cloud native development, because if you're using a volume, you can better use Amazon's Elastic Block storage, or you can go for Microsoft's virtual file management system or virtual file system. It's always better to go for that. Here, DevOps seamlessly moves an application from application to testing to production. Here, the configuration issues between the different environments are resolved. So many things are to be talked about, but my topic is not about that. So let's understand the purpose of a Docker tool. The same image is being used in different environments, irrespective of the development is in Linux or Windows or Mac OS. Everything is taken care of by Docker tool. Here, Docker is also a kind of virtualization. It's a OS virtualization. You can see the diagram. Instead of seeing this diagram, you better see this diagram. This would give you a very better understanding. Here, infrastructure means the infrastructure refers to the CPU, primary memory RAM, secondary memory, hard disk, and network, and all the kinds of hardware. That refers to infrastructure. Host OS refers to the operating system, like Ubuntu, CentOS, or maybe a Windows operating system. On top of it, we run a hypervisor. Here, in this case, the hypervisor is called this operating system level hypervisor. Here, don't call this as operating system level hypervisor. Instead, you call this as Docker. Because on operating system level hypervisor, will run three different applications on top of it. But here, this Docker is running the same application on top of it, but each application is being accessed by different team. Here, you can see that three different applications are being run. On top of Docker, you can also have three different applications with three different replicas can be run. That's why this is how we understand. Here, the application along with this binary can be viewed as a container. Container is not an application. Container is a theoretical concept which consists of application, binaries, and its configuration environment. Here is the difference between Docker engine and hypervisor. Hypervisor refers to a full hardware-based virtualization technique. Here, Docker engine refers to operating system-based virtualization technique. Here, in Docker engine, it is very much quicker, efficient, portable, and everything. Here, Docker is very efficient in terms of, on top of Docker, we run only the containers. Containers do not have different operating systems. Containers consist only of application code, and that means it's binary and dependency. It does not have a separate operating system. The instructions from the container are run by Docker engine itself. Here, this diagram can be better understood this way as well. Hypervisor installs guest OS on top of it, but here the absence of hypervisor on top of Docker engine makes this approach quite efficient. Here, the idea of Docker comes with three important components. One is called as the client, through which the end users access the Docker. We use Docker build to build an image, to build a container into an image. If a client wants to add something to a previous image, he can pull the image from the registry and he can add something, or he can add one more layer to it or multiple layers to it based on his requirements. Then he can run the image using the run command. Once it is run, a new container is created. So for a particular image, we can create multiple containers. For a particular image, we can create multiple layers on top of it. We can get multiple builds, multiple containers. Here, the three important components are client, Docker host. Here, Docker host contains the daemon or process called Docker engine. Docker engine is the one which receives the commands of the containers, or Docker engine runs the exe of the containers and gives output to the users. Docker registry is what is called as a Docker hub. Like API hub, we get all the APIs. Here, Docker hub is the one where the images of different applications are stored. Here, the images are represented, do not only the operating systems, or instead the images contain the image operating system along with the application which has been created on top of it, and along with the dependencies as well. So we have discussed about it. Here, the service of Docker, we need not do about it. Another point we have to touch upon Docker is Docker Swarm. Here, instead of using only one container or using only one node with multiple containers, we can go for clustering based idea. Here, when we talk about clustering, one node would be master, other node would be slaves. Here, CM1, CM2 refer to cluster managers. There can be multiple managers, because if one manager fails, the other manager would immediately take over. To implement cluster management for much scalability and availability requirement based applications, we can go for Docker Swarm technology. So the idea of Docker provides us with multiple advantages, which obviously are isolation of different containers, security, continuous integration in terms of microservice-based approaches, multiple cloud platforms. Because one container can be hosted in Windows data center, another container can be hosted in Amazon data center, different data centers, irrespective of the service we get from it. And it is very much rapid because we don't run OS on top of it. We don't utilize RAM for operating system for each container. It is efficient, portable, scalable. The components of Docker. While we work with when we are doing hands-on, you would have seen these tools. Docker exec. It is used to execute the particular container, to log into the particular container and see the contents of it, file system, the commands, which application it is running. Docker run is used to run the container. Docker volume, it would attach volumes to a container. Docker Hub is where we find images and along with its application. Docker Swarm is used to make up clusters. Docker Compose. When we talk about Docker Compose, we talk about full stack web application development or full stack application development. If an application consists of 3 tiers, each tier can be run in a separate container in the same node or in different nodes. This is what is about Docker Compose. The thing is about as a Docker resolved many issues in 2013, it also came with some of the limitations. Very soon the Docker was invented. The applications demanded Kubernetes. The issues with Docker were Docker was designed to make seamless integration from application to testing to production environment for single containers. When the application was about to scale to multiple clusters or single cluster with multiple containers, Docker was not designed so. In that case, Kubernetes was the alternative. Kubernetes is not a tool which was to replace Docker. Actually, Kubernetes is a tool which is built on top of Docker. Actually, Docker provides service to Kubernetes. Kubernetes is about maintaining multiple containers. Here we can see that if a container is getting crashed, when we are using Docker Swarm technology, we cannot be sure whether the container would for sure would be replaced. If a storage is if a container which provides storage service is crashed, we are not sure whether the storage would be immediately backed up. But when we talk about Kubernetes, we need not bother about its replicas. We need not bother about the application's availability. We need not bother about the storage availability. For sure, Kubernetes has been designed for providing all these things in terms of clustering-based applications. Let me come directly to the point because of short-term availability. We talk about volume here. Volume means we are, assume I am creating a container. The container consists of an operating system and also the binary of the application which runs on the operating system, and also the dependencies for the particular application to run. Now, here we talk about volume because when an application is running, it may be using databases. It may be using a single database or multiple databases, or a particular application may want to share some information with another application. In such a case, the application needs a temporary storage medium, or the application may need a permanent storage medium where when the application is running, it will store the data. When we want the permanent storage, we go for persistent volumes. When we want a temporary storage, we go for ephemeral volume. In English, ephemeral means short-lived or short time basis. Here, persistent, let me tell you this one. Let me tell you about this one. There are 2 types of volumes. One volume is from, yeah. Is it changing now, sir? Is it changing now? It's moving now? Yeah, is it moving now, sir? No. I will share it once again, sir. Is the slide visible, sir? Can I continue, sir? It's showing first slide only. Is it okay now, sir? First slide. Okay. Uh, uh, can you see the host path volume? Yeah. I will finish within 5 minutes, sir. There are, for a person who wants to know about Kubernetes volume, you need to basically understand two different types of volumes. One is host volume, or one is host volume and local volume. Another one is shared volume or persistent volume. Here, host path volume is a kind of volume, is something. This volume is a chunk of memory which we get from a particular machine. When the particular machine is always available, this volume is available. For example, let me take a worker node which has two containers in it. Let us assume container 1 wants to receive some information from the machine on top of it, from the machine on which it is running. In this case, an application developer may use this method. The application developer can give some kind of configuration information to the container through host path volume. If the application development environment or application developer wants to give some information to two containers on the same host machine, he can give two different volumes to two different applications, or he can give the same. He can give the information in one host path volume, and he can mount the same host path volume in on the two containers. Here, the thing we have to note is that host path volume is a particular file, or it's not a particular file, it's a particular directory which share with one or more containers and the machine in which the containers are running. You can understand this one. This diagram would clearly tell you. Here, when we talk about Kubernetes, we have to talk about the idea of pods also. Pods means group of one or more containers. Here, container 1 is running in an operating system along with a web server called Nginx data. Nginx. Container 2 is having an operating system, and along with it is running another web server called Tomcat. Now, in the from the host, I want to share some data to the container 1. Now, the data which I want to share is available in the host system at the mount point /mnt/data. Now, I want to add this volume to the container 1. In container 1, I can mount this volume /mount/data folder in the host at the path /var/nginx data. Now, when we go to, now you can create a file in host path in the path /mount/data, and you can see the file getting created in container 1 if you log into one. If you log into container 1 and if you create another file, you can see it in the host mount data. Now, if you want to share the same host path directory to two different containers, it is very easy, quite easy. What you have done with single container, you have got to do with two containers as well. Now, if you want to share two different directories in the host system to two different containers in the same pod, you can create volume 1. This volume 1 may refer to the directory 1 or data 1 in mount point, and data 2 may refer to directory 2 in the same mount point. Now, host wants to share the directory located at MNT data 1 to container 1, and the host wants to share the directory located at MNT data 2 to container 2. In this case, we can see that two different directories in the host system can be shared to two different containers. Also, if the two containers lie in two different worker nodes, two different nodes from the same host node, we cannot share the data. In that case, we have to have a shared file system. Usually, the shared file system is called as network file system, NFS. NFS is a kind of CPU which has a network cable inserted into it. The service of storage would be available at a particular IP address. Let us assume that we have mounted the NFS file system's mount point or NFS file system at the mount point /mount/data in container 1 and container 2 in pod 1. And also the same file system in NFS has been mounted to pod 2 containers, container 2 at the mount point slash inventory slash data. Now container 1 in pod 1 can share the data through NFS to container 1 in pod 2. Here we are able to share the data between two different containers and two different worker nodes. Here we don't talk about post path volume, we talk about NFS volume, or we can go for iSCSI based volumes. There is another volume which is called as special volume or persistent volume. Persistent volumes are not volumes which lie in the host. Persistent volumes are, see, the persistent volume may lie in the host or it may lie in the cloud. The thing is that when we talk about persistent volume, it is not about the volume allocated to a particular container, or it is not a volume which is coming from only one host. When we talk about persistent volume, we talk about volume in the cluster. Assume the host has 500 GB. I want to take 20 GB out of it. I can allocate the particular 20 GB as a persistent volume. If I do so, your Kubernetes will take this 20 GB and allocate it to the cluster, to the Kubernetes cluster, and not from the host. Also, you can take the persistent volume from the cloud also. From the cloud, you can take it from AWS as Elastic Block Store. AWS from when you're working with OpenStack cloud environment, you can take Cinder-based storage technique. For Microsoft, you can take Microsoft Azure file system based approach. Here, what you have got to keep in your mind is that special volumes are volumes which lie in Kubernetes cluster itself. Here, special volumes are created like resources. Similarly, when you want to use a particular special volume inside a cluster or inside an application, you cannot directly use a special volume. Instead, you have got to use another resource called persistent volume claim. Here, pod 1 wants to use physical volume PV. It is possible only through physical volume claim. Here, pod 1 is first created, or volume 1 can be created first, then pod can be created. Then if pod wants to use physical volume, then it has to create a claim. Now the claim would be attached to the container in pod 1. Once the claim is attached, your Kubernetes, based on the claim, it would attach the volume to the container. This is the idea. So you can see an example here. The kind refers to persistent volume. The kind refers to persistent volume. We are allocating a volume, persistent volume. Its size is 20 GB. The name of this persistent volume, we name it here as eBay-PV. Here the storage class name is eBay storage, and we have got a different volume reclaim policy. We shall see it later. Now we are creating a persistent volume claim. Why we are creating persistent volume claim? A container cannot use the volume directly. Instead, it has got to use persistent volume claim. Here we are creating a claim called name my claim. Its storage class name is eBay storage. Here storage class name eBay storage refers to the particular volume. If any container uses the claim my claim, then the eBay storage would be attached to the particular container. Now you can see this is the YAML file of a container. Here the container name of the container is container1 engines, and image is engines. Here name is eBay volume. Similarly, in the spec you can see the volumes. Name eBay volume, it's a persistent volume claim. Here the claim name is my claim. Here the container uses a volume. Here the persistent volume claim it uses, the name of the persistent volume claim is my claim. And also eBay volume is the name of the volume, and it is mounted inside the container engines or container1-engines at the mount point /tmp/persistent. Here through this YAML file, the container1-engines is using the volume. Here you can see it is using the volume eBay storage through the claim my claim. Here my claim is the persistent volume claim, and eBay storage is the persistent volume. So when we talk about persistent volume, we talk about the volume in the cluster. Balaji sir, it seems to be 6. Can I continue, sir? Balaji sir? Yeah. You told me to stop by 6, sir. Can I continue or? Yeah. So in this session, we have discussed about what is a software development life cycle, not in terms of application development, but in terms of application movement from application development environment to system to QA environment to production environment. And we have seen about IT operations team, the functionality of IT operations team, and the conflicts which happened between the application environment, testing environment, and production environment. To resolve the conflicts between these three different environments of application production, we came across a new kind of workflow called DevOps, which made use of kernel-based application development approach. Here, this approach implemented seamless movement of application from application development to testing and production through the use of containers. Here, the containers were run by Docker engines. The whole idea was called as Dockers. Dockers were suitable for making DevOps come to reality, but the idea of Dockers was not enough for big applications which needed cluster implementation. For cluster implementation, we needed Kubernetes. In Kubernetes, Kubernetes can create multiple virtual clusters, and it will give services to the end users in terms of need not bothering about number of replicas, or it leaves the administrators or IT operations team or DevOps team to be free when a container crashes or storage crashes or security issues. Kubernetes does or automates all the kinds of cluster management operations. In this presentation, we were very much specific about volumes in the Kubernetes. There are two different kinds of volumes in the Kubernetes. One is persistent volume, another one is non-persistent volume. In persistent volume, we talked about two kinds of volumes. One is host volume. Host volume is a volume which comes from the machine in which the containers are running, and and also special volumes or persistent volumes are the ones in which the application may come from the host volume or it may come from the cloud volume, but this volume refers to the volume of the cluster. So this volume, when a service or an application which is running in the Kubernetes wants to use a particular part of this persistent volume, it can use it. It can use the remaining storage to be used by other virtual clusters, or whether other applications running on two different clusters. So this is what I wanted to discuss. If you have any doubts, kindly please let me know. I am ready to give the answers possible from my side. Thank you very much for this wonderful opportunity, Balaji sir and Almera. Thank you very much, audience, for all your patience for this wonderful. Yes, sir. Thank you very much, sir.
Thank you, sir. Thank you for your informative and engaging session, sir.
Thank you very much, Honorable.
Participants, please feel free to ask any questions or doubts.
Also, nowadays Kubernetes certification is very much valuable. If you are able to do Kubernetes certification after the completion of this FDP, you are much more wanted in the software companies when you pass out a degree. Hello, ma'am.
Yes, sir.
Can we conclude this session, ma'am?
Okay, sir.
Or let me wait for any questions. Thank you very much. Yes, sir. Yes, sir. Yeah. We are very thankful to you. All our colleagues behalf and on our own behalf. Thank you very much, Balaj sir, and all the participants.
Yes, sir. Thank you.
Thank you very much. I'm also very sorry for the details talk to you in the previous. Thank you.
Okay, sir. Okay, sir. Without any delay, I request Mr. Dr. N. Balaji, sir, introduce our next speaker, Mr. Vimaraj, sir, to our participants.
Thank you, sir, for the very brief introduction of mine. So I think we are running late by 11 minutes. I will directly start the session. Sharing my screen. Not sure, sir. No problem. So I want to make this session rather than a theoretical one. I want to explain everyone like what we are doing in IT and what we are expecting in IT and what is the need for this topic in IT. Okay. Moving on to the session. First, the topic is GitOps managing Kubernetes with Git. So first, we need to understand what is all these terminologies. It can be Greeks and Latins for many or few, but we need to know like what is that. Then only we will understand the rest of the session. First, I will start with GitOps. What is GitOps? So I attended the last session. I joined before 15 minutes to see what the previous uh, presenter was discussing with you. So it's all interlinked. So you have attended multiple sessions before my session. So you would have gone through all the basics of GCP, that is Google Cloud, and how to set up a virtual machine, how to set up a Google Cloud environment, how to traverse through the resources in Google Cloud, and also how to at least to log in into Google Cloud. So it's all or like basics, and I think all would have been covered. So I'm directly moving into the topic. So what is GitOps? GitOps is nothing but it is a set of practice that use or it's kind of an improvement or it's kind of a process derivation or it's kind of a design that we follow or that we make ourselves or that we build in IT. So GitOps is nothing but a set of uh, design or a process that we follow to deploy our code. So before moving to deployment, I want to explain you or I want to tell you so what we are going to deploy or what is the purpose of deployment in IT. I will start with an example of a banking sector that we support in IT. Say for example, our client is one of the bank called AAA. So this bank has lot of operations. Say we will say it as line of business. So line of business is nothing but on day-to-day activities that we used to see in the banking sector. First is like our cards. So our cards will be split into credit, debit, savings. So multiple cards. And next line of business is loans. And you have multiple loans like mortgages, personal, and then you have all set of loans are available. Okay. So then moving on, we have next line of business is accounts, or we can say it as core banking. So core banking is nothing but whatever the on day-to-day activities that we are doing in banking sector. Say for example, it can be a fund transfer, or it can be a penalty payment, or credit score, or like the credit points that we get. So these are all related to the transactions, the applications that we are using. So these all come under the sector, the line of business called core banking. So like this, we have multiple operations in banking. So these are all like customer facing services. We have employee facing services. So for the people who work in the bank, so we have multiple uh, services that bank provides to the employees, say PF, their gratuity fund, their salary. So on this particular day, they should get salary. So this all line of businesses cannot be handled by a manual task or a manual person. Initially, we are doing it as manual. So to make this automated, then we moved on to the IT sector. So the job of IT is to do all these things in an automated way. So in simple terms, we are going to automate all the line of business, and we need to capture, or we need to process the data that is done on a daily basis, or that is transacted on a daily basis. Say for example, Vimal is going for a shopping and he is swiping in a jewelry shop for 1 lakh rupees. He is going for a petrol pump and he is paying in his credit card for some amount, and he is moving on to some hotel and he is having his food, and then his EMI comes on the day. So his EMI should be auto deducted, and once that is done, then he should move on to the next EMI. So all this process are automated. So how we are automating this process? So we are building a core system, or we are calling it as a business system for all these day-to-day activities that are doing that is going on in the banking sector. So for this business system, we will be having separate teams. Say for example, cards, we have cards team. So and we have for loans, we have loans team, and for accounts we have CBS, core banking system, and for employee we'll have it as colleague directory. So these are all examples. These are all not the actual names. So in this team we have multiple actions to do. Say A, S, D, or Y, or B, or F. So in this particular team, we'll be managing all the credits, debits, the transactions, and everything in the system. These are all automated. So why I'm stressing the point as automated is like moving on to the topic. So this GitOps is nothing but Git operations. Git is a tool, and whatever the operations or the process or the design that we produce on Git is called Git operations. So what is the use of the Git operations? So what we will do, say for example, today we had a rebate change in our Repco bank change, percentage change from our RBI. So what we will do from the backend, we have a set of jobs. Say for example, this falls under the category called core banking system. This Repco rate change, the Repco rate increase, decrease, this EMIs, and all the pending things, all the things will come under the CBS, core banking system. So what we will do, we will run our jobs on a daily basis for the banking system. If it is a retail shop, then we will be running on a daily or a weekly basis. If it is airlines industry, then we will be running for every hour to update the passenger ticket details, to update the passenger cancellation details, or it can be even 15 minutes once the airline is going to start. Okay, so that is based on the business requirement. We will schedule our jobs to run in a parallel way. So moving on to the slide. So I'll start with the first slide. So this is all about the business that is running on the GitHubs or the Git. So this is called source control to deployment strategies. So whatever changes that we are doing in these jobs, so every job will have a particular set of tasks to do. Say for example, this A is checking for customer who is having an active card and has transacted more than 1 lakh rupees on a monthly basis. So based on this, what will happen? A marketing agent will call you on a weekly basis or a daily basis or a monthly basis based on the transactions that you are doing, based on the CIBIL score that you maintain. So like as a friends, when we discuss, we'll say like every day we are getting this call from the cards team. They're asking for a credit card, they're asking for a debit card, and this loans as well. So how they are doing it? So we are running all these set of tasks. So these are all codings. So the codings are written in such a way like the business or the bank. Say for example, SBI, they will say like, boss, I want a customer, I want marketing details of the customer who is owning or who is transacting more than 10 lakhs per month. I'm going to give him a credit card for 20 lakhs. So all these business requirements are given to us in IT operations by the clients or the customers. So based on that, we will do all these jobs. So we'll schedule all these jobs. So we'll write the coding, we will make it to run, we'll make it to update the data. We'll the data can be updated either in tables or either in files. So we can send the files to the reporting team. So all these things are done by these jobs. So this is basics about jobs. So what we are doing in GitOps? In GitOps, we are providing many services. So since it's a banking sector, first we need is a security. So security is mandatory for banking services. Since we are on a day-to-day basis, we are going on this cyber crime issues. So we should have, we should protect the customers' data. Like we are all customers to the banks who are all using or having an account in the bank. We are all the customers to the bank. So we need to protect each and every customer, their data, their money, and their and we should gain their confidence. Like okay, this bank is protecting my data. So you can see nowadays, like in mobile, in telecom, it was introduced newly before 4 months in BT in UK. Okay, so there they marked all the spam numbers. Say for example, if it is not starting with this so number or it is starting with +44 or something, they will mark it as a warning. So now it is implemented in India. So now we are getting in Airtel and all the other sectors like all the alerts. So bank should send an alert based on the security only. We will get the alert. So GitOps provides the security. So you can ask like how GitOps provides security to the data. So GitOps doesn't provide security to the data, but it provides security to the jobs that are built. So data is a small entity, small metadata entity, but jobs are a bigger metadata entity. So jobs can load into a multiple tables. A job can generate multiple files. Job can stage data from file to table, table to file, file to cloud. So anyway, however we design the job, it is its job to do. So first thing is to provide security to all the jobs that are built in Google or any cloud environment. Next is like better efficiency. Say for example, this job, when the job trigger happens, like say for example, I'm going to trigger this job at 7 p.m. daily to refresh the customer data. So what will happen? This job should start at 7 sharp. If it delays by say half an hour or 1 hour, then say for example, 8 o'clock, the marketing team will be waiting for the data. Say this job runs for 1 hour. So the marketing team will be waiting to receive the data. So their job will be, or their tasks will be postponed or it will be dragged. So it should be efficient enough to do whatever task or whatever the jobs having their own task to do. So GitOps has the need to provide efficiency and it provides efficiency. Next is it provides better developer experience. So developer experience is nothing but as a developer, say for example, the repo rate has changed to 2.5% now. In the next half an hour, the bank will come and say like, no boss, it has not changed to 2.5%, it is changed to only 0.5%. So what as a developer we will do, we will make the rate changes and we'll run the job, and we will make the downstream to flow, like use this data. But if the change happens, then this code should be moving in next 5 minutes or 10 minutes, so that the customer or the bank operations which are affected are very less. So it provides it provides best developer experience, though, which means like the deployment is very fast and it is very reliable when we follow the process in GitOps. Next is reduced cost. In IT, we have this main thing is cost. In the last session, sir told like we have cloud build packages which are automated. So we have two ways of deploying the code. One is GitOps managed, which is an automated process that we follow in IT. But if you are a new learner, if you are a joiner, we can't go in that path since it is very costly. So we need to move on to the manual path. So where we will go and deploy this code in manual path? We have shell that is called Unix. So Unix is the major component to deploy the code if you are following the manual route. So Unix is a free tool, you all are aware. So we'll have we have the folders or we have the WinSAP software to be installed along when you are creating the VM. It's a virtual machine. So So this cost will be this cost management is also cost efficient, is also very much good in GitOps, and improved reliability, proactivity. So there are a lot of things that this GitOps provides, but the main things are this when we are comparing to the IT. Yep. Yeah. I haven't went into the slide till now. Yeah. So my Excel sheet is visible. It is not visible to everyone. Okay, sorry. Sorry, I have typed in a lot of things for you. Sorry. So whatever I told, I have just typed in this Excel. So I will just repeat. So this is the line of business. This is the bank AAA I was telling. And this is the line of business that I was speaking about. And cards and loans and those stuffs. And this are the operations that we are doing: credit, debit, mortgage, personal, fund transfer, and everything. And this is the business system that I was telling. And cards and the jobs that are present in the system. And the GitOps efficiency, like whatever the benefits that we get from the GitOps. So now moving on to the slide. So we are going to compare whatever we have discussed there here. So what is the use of GitOps? What is GitOps? GitOps provides continuous integration and continuous delivery. So before like around some 8 years, we will be having a model called waterfall model. So what the clients will do, they will give the requirements in single shot. They will give the requirement in single shot, and they will move the code and everything they will do in single shot, and then they will get the money and they will go out. So that is how project works. Then clients, what they felt is like, whenever we are deploying a new code into production, there are a lot of issues they are coming while after deployment they are facing. So for example, they want this code to function to collect the laptop, but that code is deleting the laptop. So it is working either way. So what they want to do, they want to have developers after the deployment also. So they move to Agile. So when Agile came in, so Agile will be like the client will give requirement when you are developing the code and moving into production. The clients will give another requirement for the same functionality or the same business. So it was a mess, Agile. So it was a mess. And then what happened to formalize or to make agile work in a designated way or in an interactive way, they move to DevOps. So DevOps is nothing but continuous integration and continuous delivery. So they will be giving requirement, you will be doing it here, and then you will be pushing it. So that will be done. So whatever you have deployed in production, if you are going to again change it back, then a new requirement should be given by the client. So it will be like a continuous integration and continuous delivery. Whatever work it is giving, it will be delivered. And if you want any change in the delivered work, then you should again give the new requirement and then we'll be delivering it. So that's how it happened. So now this continuous integration and delivery, it is nothing but source control deployment strategy. So what is source control deployment strategy? So the developer who is having or who is developing the code will have the control in his hand. So whenever the client gives new requirement, then the developer will say like, boss, the first requirement is there. I'm just pushing it to production. After that only I will be working on the next. So you will get increased timelines when you are working on this CI/CD, continuous integration and continuous delivery or deployment. So what is continuous integration? That will be the next question. Say for example, all these jobs that I mentioned here, say for example, cards is the line of business, and these are all different jobs that are present in the cards. So you have all the jobs in different sets. So you want to integrate it together. So if as a client, what I want to see is like, I don't want to see all the jobs or what the code you have written. I want to see only the output. So what is the output for all the 7 jobs? Say it is credit reporting. So credit reporting is nothing but whatever the credit score that a customer is having. So he don't want to see what code you have written, what job you have deployed, what is the tool you have used to deploy, nothing they want. They just want to see what is the reporting, credit report. Say for example, I have deployed a code or a job to publish the report for credit for a particular customer. Now the client will come and say to me like, boss, the report that you have produced is wrong. I want to add CIBIL score as a column, and also I want to see the values that are mapping to the CIBIL score. So the new requirement comes in. So again, I will be deploying code in different job called YY, and then again I will be producing the report. But end of the day, client will be seeing only the credit reports. That is the credit report document. That's it, or the report that we are producing. So what is continuous integration is nothing but whatever the new code, whatever the new requirement, whatever the new jobs that you are developing, you are integrating it, and then you are producing it to the client. So that is called continuous integration. So once you integrate all these jobs, how the client will see these jobs? How the client will able to check these jobs? So that is what we are called as continuous delivery or continuous deployment. Say for example, we have in IT we have 4 environments. One is developer environment, next is testing environment, next is user acceptance testing environment, that is UAT, and then you will have prod, that is production environment. So whenever a customer is giving a requirement, first a developer will develop here. He will mark it as success, yes, here, and he will move it to test. And there will be a tester or a testing team who will be testing the code that a developer has done. And he will mark it as success, and then he will move it to the user acceptance testing. So what is the difference between testing and user acceptance testing? Testing is nothing but it will be internal with the, say for example, it's a TCS team. So TCS internal. But when you are moving the code to UAT, that is user acceptance testing, then the user that is the client who is going to see the data in the production will have the similar ditto copy in user acceptance testing, that is UAT environment. So whatever you say, for example, the client has approved your code or the requirement that you have worked for him, then he will be accepting it into production and he will be moving it into production. So this is how the pipeline works. So here, how you will achieve this? So how you will move the code from each environment, D to T, T to UAT, and to prod. So that is where this Git tool comes in. Okay, so here if you see the third, The third point, the pipeline involves step to validate those changes such as linting, testing, and building. So that is what I explained you now. So linting is nothing but whatever you are getting as a raw requirement that you are developing it, and then you are creating a pipeline. I will say in the later session like how the pipelines are created, different types of pipelines. So this is how the pipelines are created, and you are moving the code that you are from one environment to the other environment. Right. So so all these covers, the 4 points are covered. So how are pipelines defined? So that I will say in the next slide. So moving on to the second slide. So here you can see how this GitOps helps. How this GitOps helps each and every developer to develop the code. Okay. So here, this is the application code that I mentioned. So there are two types of deployment. One is manual, other one is rapid. Usually we used to follow rapid type of deployments, that is called rapid pipelines. So this is an example of a rapid pipeline, how it is allowing, or how it is designed to move a production code into how a developer code into production environment. So here if you see this push is done by a developer. Whoever writes code, he will push it as an application source code. So whatever, say for example, card is an application, whatever the jobs that are present are called as the source codes. So then we will push it. And this cloud build is nothing but these are all like inbuilt packages that are present in cloud. So when you are opting for a GitHub or a Git tool, then you need to define the cloud build package. So what is the difference when you do it manually, and what is the way, like what is the success that you get when you use a cloud build package? Say for example, if you're doing it manually, so you need to trigger it manually. So when your job moves into production, then you need to go and type in Unix, like say for example, you have moved into a particular directory or a location, you should give the path and you need to commit it. Then only it will move to the next level. It is then if you are moving to artifact registry for all the paths, then you need to do a manual workaround. But when you are opting for a package that is called cloud build, this build will have all the set of inbuilt codes, inbuilt design to push the code. Say in GitOps, if you're going to push the code end to end from development to production, then it will follow all these processes. First is like a developer will just give his path where the code or the job is present, and he will give commit in the Unix environment. Then a trigger will be auto triggered based on the cloud build package that you have opted in. So the trigger will create a image. So it won't move the exact code what you have kept in your location. So it will create an image of the code that you are going to move to the next environment. So you can see the code that is present in your folder, and also this code will be present in the registry where Google packages that you have opted for. So that image will be created as a that will be created in artifact registry. It is nothing but a registry. Registry in the sense, say for example, you are keeping the code in desktop. This registry will mark it as okay. This guy, this team. Say for example, in cars we have CXT. That is the code. So the CXT code has moved a particular job into the next environment, and I'm marking like I'm approving like this code is present in the location where the user specified it. So that image alone it will create. It's kind of an index. It will just give an index ID in the artifact registry. Then what will happen? You will have an inbuilt Kubernetes engine. So this is also like Kubernetes engine, like in the previous sections, they would have explained like how you will deploy this resource and you will use this resource. So in this engine, what it will do, it will check like whether the deployment manifests are satisfied. Say for example, you want to move the code and you want to check the syntax that you have written. Say for example, you are a data analyst and you are moving a select star from a table. You have missed a semicolon in the end. then the engine will say like, whatever the code it is scanned, it will say like, boss, the code that you have you have a syntax error, and it will throw the error back. So that is the work of the engine, and it will again move the code. It will update in the artifact registry like basic checks or syntax check failed. Then the developer will get a notification like this deployment processed, but it has ended in an error. So the developer will again go and see like what he is doing. So what mistake he has done, and again he will write the codings or whatever it is. He will again do, and he will submit it. So when he submits again, the first code will be marked as 1.0. That is called version control. The second push, whatever he is doing, it will be marked as 2.0. So that is called a versioning. So what the engine will do, Kubernetes engine, it won't go and validate the 1.0 version. It will validate only the 2.0 version. So we won't write all these codings in the engine. So it is all Google provided service. So in this service, we have this all kind of security checks, whatever I mentioned earlier, right? So all these things will be done by the engine. The security, efficiency, developer experience, cost, so all these things will be managed. While creating the VM, we just need to select what we want. That's it. It will do all the things automated way, in the automated way, right? So moving to the third. So you can ask like, so you are telling a location where this will go or how this will go and all. So how we will, how I can go and check like where this code is present after moving it into the cloud environment or into the GitOps repository. So repository is nothing but it is collection of folders. So if you go to my folder list, so I can see list of files, list of folders in this way. So this is the same way it is replicated in cloud. So when you go and get a GitOps or a Git tool installed, then you will find two set of repositories. One is app repository, application repository. The other one is environmental repository. So what is application repository? In application repository, whatever the code, whatever the source code, whatever the job, whatever the image, so whatever the music files, so whatever you want, you can deploy in using Git and GitOps. So it is not a structured data, it is a unstructured data. So for example, whatever you are giving, the same source code will be an application itself, which means like if you go to the previous slide, say for example, you are planning to send a file to cloud, or if you're going to deploy a cloud file, you will just go give it as application source code and submit. So that in that point, your work gets over. All these things, all the rest of the job will be done by the Kubernetes engine. So it will automatically consider this as a source code, and it will apply all the sanity checks, all the deployment related checks, and it will trigger it. So, and it will enable the trigger. So if it fails, then again it will report it back like, boss, whatever you have submitted is wrong. You need to have a double check. So that is called app repository. What is environment repository? So in Kubernetes engine, so we can, as a developer, we can customize few options. Okay, say for example, we are pushing 1,000 jobs in the same time, jobs are failing. So what will happen? They will push all the 900 failed notifications in a single time, and our reporting tool, say for example, we are using ServiceNow as the tool, the ServiceNow will burst out. And we don't have that much resources to handle 900 instances in single time, the error messages in single time. We have hardly 5 to 10 members in a team, maximum of 50 members in a team. So what we will do is like, we will customize the Kubernetes engine to say like, boss, whatever the syntax or the error message that you are throwing it back, you just load it into this file or this logs. You move these logs into, say for example, to the desktop. So once we will set a threshold limit for the folder, desktop folder. When we receive, say for example, 100 plus files, then we will say like, it's a high alert. We'll mark the incidents as high priority or very critical, high critical ones. Then all the members in the team will focus only on the instance that is marked as high priority. To be simple, you are moving 1,000 jobs into production, and in that only 10 jobs are high critical. So it should be completed or it should be deployed in next 2 hours. Rest all can be done in the next day. So all those high critical ones will be sent as a trigger or a notification. Rest next working day jobs or next working day codes will be marked as low priority, and it will be present in the environmental repository. So what is environmental repository is nothing but we are splitting the environments: critical, medium, low, and next working day. So that is called environmental repository, and this should be customized by the developer who is working in Google Cloud. So this is what I mentioned earlier. When you push a change to the app repository, the cloud build pipeline run test. Test means like it does some sanity check, say syntax error, whether the file is present in the correct path, whatever the file extension you have specified, document or a Excel or a JPEG or a MP3 or MP4 or a M4V, whatever the file type you are specifying is right or wrong. So this kind of sanity checks it will do. That is called test. And it will build a container image. That's what I told, like it's a artifact registry that will create an image for the job that you are deploying. So what is containers? I think in the last session, he explained very clearly. So container is nothing but, say for example, like you think about container in real life. So in shipping logistics, you will have containers. So what you will have in containers? Say for example, non-edible products, edible products. So you will accommodate all the edible products into a container, non-edible products into a container. So basically what is container is nothing but, say for example, you are deploying 10 image files, 5 documents, and 10 spreadsheets. Okay. So all these 3 types of files will be differentiated and stored in different containers as images. That's it, to be basic. So this image, when it is created in containers, and it will be pushed to the artifact registry. So after pushing the image, what will happen? The cloud will update the deployment manifest. So what is deployment manifest? It's a very, very important term in Google Cloud GitOps. GitOps. When you are going to deploy a code, this code should be eligible to move to the next level. That is called deployment manifest. So who will decide that? So that decision is made by the cloud build pipeline. Okay. So in manual, so that's what I mentioned. In the manual deployment, you need to go and see and give this deployment manifest. Boss, I have checked all these things, and if you hit enter, then your manager will come and ask, what's boss, human errors or human errors can happen. So are you 100% sure? Then we will get a inner sin like, oh, we would have made some more, like we can do a check, we can do one more round of check, or we can do a 4-eye check or a 6-eye check, 8-eye check. If 10 people checks also, human errors are human errors. You will get human errors. So only we are moving it to the automated system called pipeline. So it will do all the tasks in a automated way. It will reduce our developers' pressure, and also the people who are going to get the this requirement output, right? So then it pushes it to the environment repository. So as I mentioned, what is environment repository? It will split the codes or the job that you have, moving it into the production, and it triggers another cloud pipeline, and that applies the manifest to GKE cluster. So GKE clusters are nothing but, so what is cluster? So moving on to the spreadsheet here. So how we have defined cluster in our system is, cards is a cluster. So end to end, staging, integrating, then doing semantics like aggregation and those stuffs, and then reporting. So this is a SDLC, software development lifecycle. So all these 4 we are considering it as a cluster. So when you are planning to move a code, you will do staging. Staging in the sense, you will get a data from a raw file, and then you will be converting it into a unstructured data into structured data, or a raw file into a usable data or user visualizable data. So that is called staging. What is integrating? So once you have moved that data, say we'll take SQLs, you will get a raw customer data in files. You don't know who is the customer, what is the data, nothing we will be there. We'll be just getting data, numbers. So from staging, what we will do, that raw data will be converting into a user readable data. Say for example, customer number or account number, the transaction that he did, transaction amount, when this transaction started, transaction start date, transaction end date, and when this transaction happened. So we will be defining the columns, and then we'll be categorizing the data, or we'll be loading the data based on the columns. Okay. So integration is nothing but in software development lifecycle, integration is, so you have customer table and you have a transaction table. So if you want to see both the data together, then you will be moving it into a customer transaction table. So we'll be integrating both the tables based on the customer ID or the account number, and we'll be loading it into a single table. So what is semantic? Semantic is nothing but aggregations. So sum of, so how many, what is the transaction that he did? What is the total amount he spent today? And what is the balance that he has? That is semantic layer. In reporting, like whatever you have aggregated, then you will be presenting in percentage, or you will be giving them in the user or the business readable format. What is the credit score? What is the transaction percentage? Or what is the transaction successful rate? What is the transaction failure rate? So this is how this cluster. So this is called cluster. So we will be making all these things into a single cluster. So it will be very easy for the developer, and also it will be very easy for the, say for example, I'm the developer today and I can move to different organization, but the code or the product that I have developed sits in there. So whoever comes in next should also be aware like what it is and how it is. So for that we will build a process, and this process will be making it as a process document, a deployment document, and also error managing documents. So we'll be marking, or we will be recording everything in documents. And if we say, for example, GK is a specific name, so card cluster. If a user or if a developer is newly employed to the card cluster, then he will go and check that cluster related documents. Card cluster. If he gives card cluster in our SharePoint, he will get all the documents in that folder. So he will go and yeah. Yes. Slideshow mode. Okay. Okay. So this is a slide we were referring to. So yep, no problem, sir. So this GKE cluster, GKE is a common name, but we can define clusters based on the line of business that I have specified here. So for a card, we can have a card cluster. For loans, we can have a loan cluster. For core banking system, we can have a core banking cluster. For a colleague directory, we can have a colleague directory cluster. So this is how the clusters are defined. And for every cluster, say in the previous point we saw, like for every job we require a manifest, deployment manifest, right? For every cluster also, if it is successful, I will show you like few branches in the next upcoming slides. So how the jobs are defined and how the clusters are formed, that will be in the next slides. So to be in single point, like this deployment manifest, how it is needed for each and every single job or the single code that you are moving into production. Similar way, whatever the clusters you are defining, for all the clusters, you need a manifest. Okay, so the deployment manifest is required for each and every job and also each and every cluster that you are moving into production. So this is all the build phases. So whatever that I'm telling you is build. So you are building the environment. So you are making a code, you are developing a code, you are testing the code, and you are getting the customers approvals for deploying it, and you are deploying the code. So we are in the end stage. Whatever the code that we are planning to move into production, till that it is in the build state. So what is the difference between build state and the next state? That I will explain in the upcoming slide. So as a developer, so that's what I explained in the previous slides. As a developer, what I will do, I will make a code change in an existing job, or I will make a new, I will type in a new code, or I will develop a new code. And what I will do, I will just commit it, commit to the app repository, commit and push. If you hit commit in the, if you give the directory name and the file name or the job name and give commit, it will automatically move to the app repository. You may have a question. So how this engine, cloud build engine is, or Kubernetes engine identifies the app repository. So while building a cluster, for every cluster, we will be providing a separate application repository. So each and every application will have a separate repository. For cards, we have a cards application repository. For loans, loan application repository. For other LOBs, line of businesses, we'll have different sets of repositories. So these are all customized ones. We need to provide it in the initial stages when you are building the CI/CD pipelines. Maybe in the previous sessions, this should have been covered. So when you define your repositories, from there only you can move your code. The change code will be moved into that repositories. Okay, then cloud build application repositories. So what will happen in the application repository? So it is in a detailed way. So when you hit a commit in the Unix server, okay, it will send a trigger to the cloud build or the Kubernetes engine. This engine will receive a trigger stating like, okay, this guy with the employee ID so and so, or the customer ID so and so has hit a commit, and some new code or new items are coming in. So it will first detect the new commits. Whatever you are committing, first it will detect it. Then it will run the unit test. So that is what I mentioned. So all the syntax errors and those stuffs and everything will be, all the sanity checks will be done in the run unit test. Next is container images. So whatever the tests are done, then it will create an image in the container. So containers, as I already mentioned, it will split based on the similarities or the business usages or type of files. So whatever the similarities it is getting, it will make it into a container and it will build an image. And after the container image, it will push the container image. Okay, so it is telling like it is sending a trigger. Boss, I have checked all these things and from the test unit, and I have received a container to build an image. So I need to build the image. Just it will send a trigger. So that is called push container image. Whatever the image it is created, it will push it. Then it will update the manifest and push to candidate branch of environment repository. So whatever the container image has created, this manifest will be is like a nod of giving yes, I approve, like all the changes, whatever is committed is looking fine, and the container images is created. So this is ready for the next level. This candidate branch is ready for the next level. Then it will push the candidate branch to the environment repository. So until this cloud build repository, everything is automated. So all this middle part is fully automated. So the manual work falls only here till we commit the code. Then moving on to the environment repository. What will happen in the environment repository? So it will detect the change in the candidate branch. So here, say the candidate branch is cards cluster. So this cluster has sent some code and it is ready, and it is there is some changes that we need to deploy. So it will first detect it, whatever the change that we are pushing, it will detect it, and then it will apply manifest to the Kubernetes. So this trigger will go and hit the engine. So what the engine will do? So the engine will check all this, whatever I said previously, right? It will check all the things in a second, in second time also. So this manifest is nothing but full of packages. So you can directly go and see in Google Cloud, like all these packages are available in if you go to Google Cloud tutorial, you can see all these packages. One best example is like JavaScript. So evolution of Java. So first we need to write all the codings in Java. So it's called core Java. Then our guys got hand pain. So what they did, they want everything handy. Then what they did, they don't want to type code. They want they made everything as script. Then only JavaScript evolved. Okay. So when they need a script, they will just give, like in our C++, we'll give, right, hash include conio.h, hash include stdio.h. So everyone would have do that, but we don't know like what is there in the conio.h, what is there in stdio.h. Similar way, JavaScript. So in JavaScript also, like people don't know like what script to involve, and multiple scripts are there. I don't know which script to select. Then the evolution of Node.js and other JS. Node.js means it will be in nodes. A node will have multiple JavaScripts. If you invoke the node, then you can get a visual. Say for example, you are sending input as an image, then you can get an image with the background music. So this is called the packages. Okay. So similar way, Google as manifests for the Kubernetes engine. So these are all like, if when you opt for this Google Cloud cloud build, then all these things will be like a package, right? So based on the Google build, whatever it is present in the packages, this manifest to Kubernetes will be approved. It will approve the change that you have made and update production branch with the applied manifest. So whatever you have developed, so there will be a bit confusion here. So then what is this? It is nothing but these are all developer based. Okay, all these dev, test, UAT and prod are developer based. As a developer, I will develop a code. I will test internally with my team. Then I will test in the user environment. So the clients and the developer will be in sync. And then I want to move this code to production. So these three are developer based. And now what we are speaking is production based. So till here, you have access to edit, modify, rewrite, whatever you want, you can do. Send multiple code change or multiple job change, everything you can do. But in production, once it crosses this UAT to production, you can't touch anything. You can't even copy few codes. So that is how it is restricted. Okay. So this update will be run in the production branch when all the manifests are applied. Manifest in the sense S node. It is giving a go ahead and then it will be deployed. So this is all about the flow of the code that you are moving based on GitOps and the Git tool. So similar way, whatever I explained, it is in the next slide. Create Git repositories in cloud source repositories. Okay, so you can ask a question like, boss, can I create this repository in my own desktop and I can move the code? Shall I able to move this code into cloud? No, you can't. Since whenever you are working in Google Cloud environment, you will be creating a virtual machine. So the virtual machine will be giving all the basic things. What is the RAM? What is the name of the virtual machine? And what is the capacity of the virtual machine? What is the network security group? All the things will be in virtual machine. So you can't move a code from your own desktop to the Google Cloud environment. Whatever you are doing in the cloud environment, in cloud path or in cloud repositories, in cloud Git repository, that only you can use for the production or the movement of the code from one environment to the other environment. So create a container image with cloud build and store it in artifact registry. So this is the standard process that we saw in the last image, and creating a continuous integration and continuous deployment pipeline. So what is CI pipeline? What is CD pipeline? So this is CI pipeline. Dev, test, and UAT, which means like whatever is in the developer scope, this is called continuous integration. As I mentioned here, so here you need one more job to do. Then in loans or CBS, then you will have you will create all the 8 jobs or 7 jobs, whatever it is, and then you will move it to the next environment for testing. And if the client wants one more job to deploy 1, 2, 3, 5, then you will be creating the job and you will be sending from dev to test and test to UAT. So this is called CI pipeline. What is CD pipeline? CD is continuous deployment pipeline. So in continuous deployment, whatever you are having here, say for example, you have 5 jobs to move into production. So what you will do, you will create continuous deployment pipelines stating like, for this job 1, what is the dev test? What is the dev test? And what is this for 5, for 2, for 34, for 78? For all the job numbers, you will be creating this deployment pipelines, and this once it is accepted by user, it will be automatically moved to the production. So that is what we saw in the previous image. Okay, and testing of CI/CD pipelines will be automatically done by the cloud build, the package that you are opting in. Okay, then moving on to the cost. So let me tell you like what is the cost of the each and every deployments. So what is the price of? So now we have spoke about the engines and all the sources, artifact registry, Google cloud build, and all the things. So what is the cost involved? So based on this cost only, we will be opting the services from Google. Say for example, if you are using Google Kubernetes engine, the pricing for that is around $0.08 dollars per hour in virtual CPU. This varies. If you are using a low throughput or a low input CPU, then it is the basic price. It will go up to $5 or $6 per hour. Say for example, a developer will work for 8 hours, and if he is not logging out of this Kubernetes engine, it will charge, say for example, 10 pounds per hour, 80 pounds per day. So if I'm working for 30 days, then you can calculate the price. It is for only one engine. It is for only Kubernetes. So we have multiple softwares also. So the softwares that we have currently is Teradata. We have Tableau, and we have IBM in Google Cloud. Now we are working on migration from a legacy technology to Google Cloud. So here we have multiple software. So that software cost also should be bared by the organization. And Google Cloud repositories. So if you're using a cloud sourced repository, so what is the cost of the cloud source repository? If you're using up to 5 repositories, so in as a developer, like we use around some 50 to 60 plus repositories. Okay, so in 1 to 5, so you will be paying up to 50 GB storage. Okay, it is repositories are priced based on the storage. So for per GB, they can charge up to, like, say for example, $0.5 or $1. So we will be using in terabytes. So even a single table, what we use is having terabytes of data. So cost wise, it is very, very costly if you use a Google sourced repository. So only what we will do, we will customize it. We will create our own repositories, and based on that, we will be deploying the or moving the code into the application repositories and also to the environmental repositories. So application repositories are this bit less in cost, but environment repositories, they are holding clusters. Okay, clusters is multiple jobs and multiple applications, so it will be more in cost. So, and artifact registry pricing, like we have 3: storage, transfer, and vulnerability scanning. So whatever you use in artifact registry, you need to pay. That is the thing. So if you're getting a storage in artifact registry, you will pay some money. I have given the link. You can go and see very well in the Google site. And data transfer. Say we saw there, right? We are transferring data from container to image and Google manifest, and everything is cost. So how many commits you are doing? So how many jobs you are transferring? What is the size of the job? What is the security that you are building? Say for some jobs, we'll be marking it as high critical or high. It is only high confidential, then public. So we'll be giving emails, right? Similarly, we should mark the jobs or the files that we are moving, right? So based on that, the cost varies. and the engine, obviously Google Cloud package that we are getting. So what is the cost of that? So everything is cost. So I have given a Google Cloud's pricing calculator here. It is available in Google online. So if you are going to if you are going to log in into a cloud environment, you will get some dollars, say $100 or $200. Based on that money only, you can work, or you can traverse inside the Google environment in the VM virtual machine. Okay. So for that, you can see how much it is. Say, for example, you're going to build a VM. What is the price? Say £5 per hour, $5 per hour. And what is the software you are going to deploy? Say GitOps, in GitOps, you have Git as the tool. For that tool, what is the cost per day or per hour or per minute? So everything you can calculate here, and based on that, you can build a cloud environment and you can work on the Google. Okay. Moving on. So whatever now I have told is a theory, okay, like practically what we are doing, how we are doing, and what it is currently in IT, what is the process that we are following, right? So there are some basic comments. Actually, it is not a big coding related topic, GitOps and Git. It is just a moving of code from one area to other area. That's it. So here, if you want to, that I told, right, like if you want to see some samples. So if you are logging in into this VM virtual machines, if you open a tab called shell, there will be shell scripting. There you can use these commands to see in Google Cloud Platform, this Kubernetes engine samples. So this engine itself, they have multiple engines based on the requirement that you have. So you need to study what engine is required for what kind of job. Say, for example, you are doing a data related job, there will be a different engine. If you are doing a web development related job or web development related developments, then you need to opt for a different engine. So whatever the work, say for example, you are an Android developer, then you need to opt for a different engine. So its engine is nothing but the functionalities or the set of predefined process that are inbuilt and provided by Google. So this you can see in the Google, this GitHub. So you need to clone this. So that is what here. If you give the clone command, it will clone it into the directory that you are giving. So all this will be done in Unix only, shell script. Say for example, your project is something you are building called Hello project, Hello Cloud Build app. So you need to define your project name. So these are all the codings that you can, basic codings that you can use for you can use for visualizing what is present and how it is present. Okay, when you get to know answers for these two questions, what it is and how it is, you can easily go through the next phases of Google Cloud. Right. So next is creating Git repositories in Google Cloud Source. So whatever I have shown in the previous slide is nothing but the codings that you need to type in to see, like those will be like documents, okay, like JSON scripts, or it will be like bad scripts. Bad scripts is nothing but it's executable scripts like that. But you can see the same in the Google Cloud portal, that is the environment or the resourcing tab. So in the previous session, sir told about Docker. So what is Docker? Docker is nothing but a trigger or the engine. That's what Docker is nothing but a trigger. That's what he meant. So how you will create a Docker? That is a major question. So if you want to create a Docker, I will just give like a self-studying thing. I don't want to go into deep. It's a big topic. So in Docker, if you see, you need to provide whatever you are providing for creating a VM. You will provide the server location. You will provide the type of VM, whether it is for a development environment or for testing or for deployment or UAT. So like that, you need to mention what is the server in which this Docker should be maintained. So here they have given central US central one, and what is the trigger or a Docker or a Git, whatever it is. So that we need to create it, and in the Docker we will be getting the package. So here the package is nothing but we have opted for some development package. So that is what it is here. and this is my repository. Whatever I told, so repository is a folder, and whatever the cloud build. So hello cloud build is nothing but a file name or a image name, anything it is. So here, whatever we saw here, right? All these jobs will be here in the cloud build. Instead of cloud build, we'll have multiple jobs in my repository. If we go a cd /, then we can see like whatever the jobs, what are the jobs, or what are the codings, what are the images, what are the files that we are planning to move to the next environment will be present in this my repository. Okay, so this is all about GitOps and Git. So GitOps is nothing but a set of process that we follow to move coding from set of coding from one environment to the other environment. So I missed to say about pipelines. So this is the last topic of the session, pipelines. So I will I don't have an image in image for pipelines. I have in my client laptop, but I can't show it to you. But I will tell you like how pipelines are built. Say for example, we'll take a retail shop, and here I will explain you the branches. So in a retail shop, you have multiple departments: sales, marketing, you have billing, then you have stock management, and you have transportation for shipping your products from one location to other. It's a big, say for example, it's Marks and Spencers. It is one of the biggest retail shopping malls or shopping showroom in UK. So you have your transportings from your hub to your retail location. So in sales, what you will have? You will have as a salesman, as a sales, what you will have is you in a retail for it's a dress shop. So you will have men's, women's, kids or children's, and you have all the set of variety. These are all like I'm telling these men, women, kids are like generic data set. If you go inside men, then you will have pant, shirt, and different varieties of pant, shirts, belts, shoes, gloves, vest, and everything. So similar for women, similar for kids. So it's a big data set or a big metadata. And marketing. So marketing, there are multiple types of marketing. So you have online marketing, you have showroom marketing, and you have ads for marketing, and you have boards, or boards in the sense like the links you will be getting on your emails or messages, or you will get phone calls. So these four are like small metadata, and inside you have multiple huge data. Okay, in online, how you will contact? You can contact through social media, you can contact through websites, you can contact through multiple options are there. So in showroom, you have showrooms in multiple locations, and every showroom will have its employees, it have its own stockpiling, stock managements, and everything. And so similar for all the data sets. Billing, you can go for online cards, credit card, debit card, and you can go for a uh, a voucher payment, and you can pay using multiple ways. You can pay your billings. Okay, so these are all like simple metadatas. And if you go into cards, if you put a card, it declines, then it should capture the declined amount, and it should not update in your billing, and it should show like still you have not paid your bills. Then again you should put a card, and if the card doesn't work again, then you should again check for the other options. Then you will go to the front end screen and you will go for cash. So like that, multiple real-time scenarios will occur. So all these things comes under uh, 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 so for all these daily used business related terminologies or the business requirements, we will create a pipeline. So for sales, we'll have a pipeline. And for marketing, we have a pipeline. Say this pipeline is named as sales application, and this is mark, something like that for the marketing one. And for billing, you will kind of having a bill something. So whatever the names that those are user defined names and approved by business. So this is nothing but pipelines. So pipelines, now you can able to understand, like you can able to visualize what is the use of pipelines. So if you are going to trigger a pipeline, so this pipeline will trigger into this is the main job or the application. Inside that application, you will have sales, and inside sales, you will have men, women, and kids. So this is how the branches of the pipelines are built. So under, say for example, we'll take billing. In billing, you have cards, cash, and voucher. So here in cards, you have these different jobs. Okay. So all these jobs will be in tree structure, and also we should uh, we should give proper sequence of execution of the pipelines. Say for example, once sales is done, then only billing will happen. So if you are running billing first, and if you are going to trigger the sales pipeline later, then it will be a mess up. So you will go for a customer, say name like Bimal, but you won't file in sales details the customer name. So you should sequence it. So for sequencing, first you will create a pipeline and you should sequence it. For sequencing, we have tools like tools called schedulers. Schedulers are nothing but it will say like after sales, marketing should run. After marketing, billing should trigger. After billing, I should check for cards and cash. So whatever it is. So it is like a sequencing the business structure. So what are schedulers? So schedulers' job is to sequence all these pipelines and the jobs or the business requirement that are present inside it. So what are the types of schedulers we have? So we have in Google provided, we have IBM, so that we are using in our current project. IBM scheduler, it's one of the slowest scheduler, but very limited cost. It is very cheapest scheduler. Okay, it's IBM provided. So it is a web page actually, basically. So if you are going to see like what is the pipeline, you need to click in this. Say for example, you are in the scheduler, you have a job called kid. If you are clicking this kid, it will show multiple options stating like you want to see the predecessor pipeline, or if you want to see the predecessor jobs, or what is the successor of this job or this application. So that is how the scheduler schedules the job. So this is the use of the scheduler. And you have control M. Control M is a scheduler, and you have TWS, Tivoli schedulers. So these are all like used in major IT firms, all the schedulers. So basically, when you are creating a pipeline, you can't create and push it to the production. So these pipelines should be streamlined. You should streamline a pipeline by providing first you should know which is the first, which is second, and which is the sequence you should know. So pipelines are nothing but pipeline is a bigger metadata set which holds multiple branches of the business or the business line of businesses. So that is all about pipeline. For scheduling a pipeline, you will be using this schedulers. And last point to add. So now you will have a question. I have moved all my code into production. So say for example, all these jobs are accepted by user and they are moved to production. So how the user will trigger the job, or how the user will deploy the job, or how the user will run the jobs. So it is similar to pipelines. What we will do, we will say for example, control M is the scheduler, and you need to run all these jobs. So first what you will do in control M, you will first give what is the uh, uh, business system. Say for example, it falls under cards. So cards application. it's a bigger metadata set. Inside cards application, you will have jobs. Say for example, you have jobs called 120, 130, and 140. So so when you just trigger this cards application, what will happen? This 120, 130, and 140 will run together. Say for example, the table used in 120 should be used in the 130 job. So what is the basic business need is like this 120 should be successor, or this 120 should be predecessor for 130. So all this kind of syntax and coding you can do in Control M, or basically in scheduler. Say for example, 130, it is dependent on some other application. Say for example, it is dependent on colleague data, colleague directory. So in Control M, you'll have one more application called colleague directory, and this 130 and colleague directory has jobs called 1, 2, 3, and 4. But this 130 should run after this third job is completed. So how you will write the coding here is like, for 130, predecessor is job number 3 and should be marked as success. If this job fails, then 130 should not trigger, which means like the data is accessed from colleague directory to the cards application. So like this, you have multiple clusters. So whatever the clusters we are deploying right from the environment repository, all those clusters we will be scheduling it on back of a scheduling tool, right? So this is the use of the scheduler. So now what we have covered is like, what is GitOps, what is Git tool, and what is the process or the design or the flow of code deployment. I have not covered what is the code, how you will write code and all, since it is starting from the deployment phase. This tool is fully for deployment. It's the continuous integration and continuous deployment process. So that I have covered, and I have showed you the already existing in Google, those images and how it works, how the flow is. And now I have told you like what is pipelines and how these pipelines are built. I have given you 2 line of business as example. One is banking system, one is retail system. And now I have covered the schedulers. So in scheduler, what you are going to do, you are going to schedule the job. That means like you are going to sequence the job or the applications. So that sequence should not affect the data or the business that your business user has requested. So this is all about GitOps, and also I have explained you like what is cloud build, what is Kubernetes, and how you can customize it, and what are all the options that is available. So this is all about today's session I want to cover. Thank you. Let me stop sharing my screen. And now it's questionnaire. So I think you all would have listened to my session actively. So now you can ask questions, whatever questions you have. It can be basics in the topic that I have covered, or also in the cloud, whatever you have questions, you can ask me based on certifications, based on the next gen technologies. So anything, it's open for questions. Thank you.
Participant, does anyone have any questions or doubts? Kindly clarify with sir.
Yeah, Satya she has raised her hand. So you can unmute yourself and you can flag your question. Okay. So Professor S.A. Jain. Yeah. Sir, you have asked about the certification that we need to do. So I think everyone will have doubts about certification. I will provide you what are the certifications that are available and the cost of the certifications. So we have around 12 plus certifications in Google Cloud. So currently what I have acquired is a data engineer in Google Cloud. So data engineer is nothing but whatever you are working in your first year or second year in SQL or Oracle. So the next versions like Teradata, and now it's big data, and in that only like it has moved on. So if you are going to do a data engineer certification in Google Cloud, it will cover all the BigQuery related things. So BigQuery in the sense how to query in Google, how to use BigQuery for creating tables, accessing tables, building DDLs and DMLs, updates, inserts, and how to make the code into scripts and how to run the scripts, and all the things will be covered in the data engineer certification. So it costs around I think $120, so it should be around 10,000. So we have in DevOps. Now I'm currently uh, uh, done this Google Cloud Architect certification. It cost me around some 10,500. So if you go to Google website, you can see all the certifications. For DevOps, you have 3 different certifications. DevOps for continuous integration and continuous deployment. So that will be used specifically for deployments only. Whatever the session that I have covered, this is ditto to the certification. It will be CI/CD DevOps. And you have one more certification called DevOps Engineer. In DevOps Engineer, you can see like what are the DevOps tools that are available, what are the deployment strategies, what are the deployment uh, tools like Git. We have multiple tools, Git, Docker, and etc. Multiple tools are there that you can see. And one more thing is like if you go to Google website and if you register there for a certification, you will be eligible for a voucher. Voucher is nothing but you can, if you get the voucher, then you can schedule your exam, and if you apply the voucher, you can take the certification for free. So Google is providing around some limited number of vouchers to the individuals who are interested to take Google Cloud certifications. So if you go to the Google website, you can see like if you type in Google Cloud voucher for this certification, then it will take you directly to the page. So there you should do 70% of theoretical and things, and 30% of hands-ons. Once you complete around 90% of the course, then you will be eligible for the voucher. So you can opt in for a voucher. I did both the certifications using voucher. It's free of cost. So if you are working in an organization, say in IT, so you can give your organization employee ID, and you can say it as work. And if you are a student, or if you are in a non-IT professional, you can give your personal email ID and you can select your profession. So that will give you this all these details about the voucher. So for students, if you want to say, for example, you will be for faculties, if you want to provide information to your students about the current technologies or the current trend in IT. So like the system that I'm working, it is built in 1960s. So we haven't migrated to any other system. We are migrating only to Google Cloud. So Azure is not accepted by UK. So in UK, government approved and government allocated cloud systems are 2. One is UK provided cloud system and the other one is Google Cloud. The only thing is like in Google Cloud, we have all the servers in US. That is the only problem. So, but in upcoming, for the upcoming years, like 1 or 2 or 5 years, you can see Google Cloud at its peak. So you can trust and you can do Google Cloud certifications, and you can say to your students and also your friends and everyone to move towards Google if you want to move to the IT environment. Okay, so If there are no questions, can we wind up the session? So I think the next presentee will be waiting.
Okay, sir. I would like to extend our heartfelt gratitude for your outstanding presentation. Thank you, sir.
Thank you, ma'am. Thank you, sir. Thank you all. Thank you all. See you if I get a chance to meet you again. Thank you all.
I request Dr. N. Balaji, sir, to introduce our next speaker, Dr. N. Shivakumar, to our participants.
Okay, good evening to one and all. So, yes, good evening to one and all. So, probably I'm going to discuss today about security aspects in DevOps, right? So, let me share my screen. Okay, hope my screen is visible. Fine. So on the first day, I think I have introduced about DevOps, right? So how from waterfall model, how it has been evolved to agile, from agile, how it has been come over to DevOps. So that is what the introduction part I have given you on the day one. Today, what I'm going to do is, yes, DevOps we have. What if security that has to be added to this particular DevOps, right? So in all the phases of software development, right, we are going to talk something about the security features and how important is a security that has to be accommodated in every phases of software development life cycle. And that too, in particularly, if you develop something based on DevOps principle, so how this particular security that has been embedded into that. That is what the session is all about. And I'm not going to give any sort of hand-on session and all. Probably again, I'm just going to introduce a new thing called DevSecOps. Right? It's a combination of development, security, and operations. Earlier, we have been talking only about security. Earlier we have been talking only about development and operation, how they collaboratively work for a successful software development. That is what the discussion is all about. Today, if the security personality, meaning if I would like to embed security also within this particular development environment, how good it is going to be. That is what the session is all about. So basically, DevSecOps stands for development, security, and operations. It's an approach to culture, automate, and platform design that integrates security as a shared responsibility throughout the entire IT life cycle. So we have been talking about analysis, design, implementation, testing, and everything. I might have told you during the testing phase, probably testing is not the one that has been accommodated only in the testing phase. Testing has to be accommodated in every phases of the life cycle. Even testing has to be accommodated in analysis. Testing has to be accommodated in design. Testing has to be accommodated in implementation, and of course in testing phase also. The same way, now what we are going to do is we are going to accommodate the security in all the development life cycle phases, start from the beginning to the end, right? So because when you incorporate security at the early development of product, probably you can get a quality secure software. So that is the intention of incorporating the security in DevOps. And when it comes to development is concerned, probably development focuses on writing innovative code. Obviously, it is an implementation. Now, I told you like security is about to be incorporated. The primary purpose of security team is to ensure every step of software development as a risk-free, meaning there should not be any trouble, there should not be any intruders, there should not be any sort of privacy interrogations, right? So everything that has to be incorporated in every phases of software development. And of course operation teams, obviously that guarantees the smooth deployment of software at the client end, and of course they are the one who monitors the performance also. So all these three things are going to work in a collaborated way, and that is what we call it as DevSecOps. And obviously there is a difference, right? So among DevOps and DevSecOps, right? So DevOps, we already told you, it's all about only development on operation team that has been getting involved. But when it comes to DevSecOps, obviously the security also has been incorporated. As I told you, the security plays an integrated role in the complete life cycle of the application that we are about to develop, right? And of course, security is a shared responsibility integrated from end to end, meaning from the scratch of software development until the deployment. So that is very important, right? It's all about providing or developing a secure software. That should be the motto, and that should be the ultimate aim when we develop a kind of software. And when it comes to DevSecOps in the SDLC phase, meaning generally like in conventional software development method, what happens is this security testing will be taken care as a separate process. Maybe at the end of all the software development, probably this particular security testing will be taken care. Probably you might have come across, right? Normally we go for unit testing, integrated testing, and finally we go for system testing, right? Unit testing is the one that we do at the initial level, right? One component developed by a particular programmer, he will test his own component. That is what unit testing is all about. Once individual components has been tested, that has to be tested at the integrated way, because a unit that performs better or performs correctly as an individual unit might not work as expected when that has been integrated, right? So that is a fact. And once integration is also been over, then we go for the overall system testing. This system testing is only incorporates security testing, performance testing, stress testing, and recovery testing. All these sort of testings will be taken care in the system level testing. So basically at the end of testing, then only the security will testing will come into picture in the traditional SDLC model development, right? The security team discovered security flaws only after they build the software. That is what a kind of, I can say it's a disadvantage, but that is the point where we can overcome this sort of issues. And this DevSecOps framework improves this particular SDLC by detecting the vulnerabilities throughout the software development process and until the delivery process. So that is an impact of DevSecOps. And when it comes to the components of DevSecOps, right, there are 5 important components, starting from code analysis. Obviously, right, so when you build some sort of code, we have to ensure whether there is any sort of vulnerabilities. Basically, vulnerabilities is the place where the security breaches might happen. So we have to ensure that code analysis will happen. And then change managements, because a particular code might be changed frequently by other developers also, because all other developers also are incorporated as a team. They have been working in this, so many people taking care of a particular module into the code probably incorporates so much of changes. So we have to track and prevent the changes that exhibits some sort of risky nature, right? So that is also very important. And then third one is compliance, meaning whether whatever code that you have been developing, whatever design you are coming out with, everything or under the regulatory policies, because every software development has its own policies, right? Every companies has their own policies. Probably you might have come across something called ISO. Even software companies hold ISO. And you might have come across something called CMM, capability maturity model. At one level, probably like CMM level 5 companies and all will have some sort of standard in developing their code. They have some sort of structure. They cannot just go across building a software development in a autonomous manner. So they have to follow some regulatory adherences. That is also very important. And fourth one is threat modeling, right? So because we have to understand what might be the possible potential security issues that might be a prospective thing in a software development. So understanding that, we have to safeguard the vulnerability part and the risky areas also. And finally, security training, right? Obviously we have to give some sort of awareness among the programmers, among the software development team members, giving them the best practices, right, and train them so that they can understand where the security issues might prosper during the software development process. So these are the components of DevSecOps. And this has been explained over here, whatever I told you, right? Code analysis is the process of investigating the source code of application for vulnerabilities and ensuring that it follows security best practices. So we have to analyze the code. Software team use change management tool to track, manage, and report on changes related to the software or requirement. We already discussed this requirement changes, right? When you get new requirement, we are about to do that particular changes in the existing design and existing code, right? So this in turn, right, when you do more changes, that in turn might be a vulnerable part that has to be taken care during change management. And compliance management, as I explained, there are some sort of regulatory requirements, right? Say developers can use only AWS Cloud HSM to demonstrate compliance with security, privacy, and anti-tamper regulations such as HIPAA, FedRAMP, and PCI. So unless or other than these regulatory bodies, right, a sanction the models or the code structure that has been developed, it cannot be a software, I mean, it cannot be a quality software, right? And fourth one is threat modeling. So this DevOps team, and particularly this DevSecOps team, investigates security issues that might arise before and after deploying the application. That is very important. We normally say prevention is better than cure, right? So that is what, even before the particular security issues might arise, we should be well in advance. We have to understand what sort of threat that might arise even before. So they are supposed to be fixed, right? And we all should also take care of any sort of new versions that has been coming out, and we have to update those versions also in the application. And finally, security training, right? So learning is a continuous process, right? So new security threats or new security issues might prosper at any moment of time. So security training is very, very important, and obviously that involves training software developers and operations team with the latest security guidelines. This way, the development and operation team can make independent security decision when building and deploying an application, because developers, they take care of their own operations, their own activities, and operation team will take care of their own operations, starting from deploying to the maintenance, right? If that is going to be the case, they individually should be aware of the security aspects, so that they parallelly take care of the security risk in every stages of development. And what might be the common tools that might be used by this DevSecOps, right? So we have something called static application security testing, software composition analysis, interactive application security testing, and dynamic application security testing. So these are the 4 important tools that this DevSecOps has been making use of. When it comes to static application security testing, what it does is it finds the vulnerabilities in proprietary source code. I have a code, software has been developed. Now it is time to ensure whether this particular software is free from any vulnerabilities. So the static application security testing can be conducted, right? And software composition analysis, right? What they are going to do is, it is a process of automating the visibility into the open source software use for the purpose of risk management, security, and license compliances. So all these things are supposed to be collaborated and integrated, right? So we have to take care of risk management, right? So there are so many types of risk probably we might have come across in security aspects. That security, I mean, that risk management, security management aspects, and this license compliances are supposed to be incorporated and integrated. And interactive application security testing, right? So this tool is used to evaluate an application's potential vulnerabilities in the production environment, right? So normally there are so many environments with which the software development happens: development environment, production environment, test environment, right? So now this takes care of the production environment vulnerabilities. Okay. And one more thing is this application software testing, interactive application software testing, consists of special security monitors that run from within the application, right? So there is not going to be any external tool that has been used to test this particular application. There will be some code that has been integrated within the application, right? And finally, this dynamic application security testing, right? So this testing is going to take care with respect to the hacker's perspective. What we are supposed to do when there is a external threat, what this particular intruders, how the intruders model, right, their threat activities to inject risk or security threats into the system. In that aspects, this security testing will be taken care. So this tool will mimic hackers by testing the application security from outside the network. As the third man's perspective, right? What I should do when the hackers try to inject errors or security threats in this route, right? So in all possible permutation and combination, we have to analyze and ensure security. Normally, a scenario normally people come across policemen have to think in the perspective of a thief. Then only he can catch hold of the particular thief, right? At the same time, thief also probably has to think in terms of police, right? Then only he might not get caught. So this is what normally a scenario that pops in. The same way, when you develop a particular software, you have to think in terms of a hacker. What are the possible ways in which he can get into our system, right? Analyzing that, so you have to provide security. Okay, so these are the 4 common DevSecOps tools that has been used. And next thing is, what might be the challenges? Probably whatever we do, obviously it will have some advantages. Of course, those will also have some challenges also, right? When it comes to challenges, the first and the foremost is cultural resistance, right? So what happens is, so far we have practiced something other, and now we are subject to practice some new practices, right? Say the software and security team often clash on priorities, delaying DevSecOps adoption, meaning once development is over, then only security team will come in. So what we claim is, it has to go parallel, right? So during the development process itself, security should also be ensured. And when it comes to the developer's perspective, right, his only motto during the development is going to be, all the functionalities involved in this module has to work fine. Then only he will think about the security aspects, right? His ultimate thing is the basic working of a particular software, and he is supposed to deliver his module on time, right? Functionality is very, very important than security with respect to developer's perspective. So this DevSecOps, what it tells is, during the development itself, this security should also be incorporated. And that's why the clash between the development team and the security team might normally happen, right? Probably the only solution is the leadership. The leadership must unify them to ensure secure and timely delivery. So this is one sort of resistance that normally among the team members, right? And next thing is the tool complexities. Because when it comes to this DevSecOps, there are so many tools that we are supposed to incorporate, integrate, right? When it comes to DevOps, we have been talking about the continuous development and continuous integration, right? These two are very, very important in DevOps. So when you like to sustain this continuous development and continuous integration, probably security plays a very important role. So when it comes to security is concerned, many tools I'm supposed to incorporate into that, right? So that in turn might be a challenge, right? When it comes to implementing this DevSecOps. And next thing is how this particular DevSecOps works, right? From where it begins and where it can be ended up. Say, initially, the first and the foremost is, we have to adopt the DevOps practices, right? So we have to first ensure whether we are started practicing the DevOps. Once we ensure, yes, right now I'm not into Agile, right now I'm not into a traditional waterfall development or any other process model. Right now I am into the DevOps operations, DevOps practices. Right? So that is very, very important. Once you go for DevOps, then only you can add security into DevOps. Right? So first, adopting DevOps practices is very, very important. And second thing is shift left principle. So we have something called shift left principle and shift right principle. Basically, when it comes to shift right principle, that is the one traditionally that has been followed. What is shift right is, you go for analysis, you go for design, you develop, you complete your product. Now I go for providing security for the developed software. So that is what shift right principle. What shift left principle talks about is, instead of starting your security aspects at the end, why can't you start your security aspects at the beginning itself? So security starts early with code, right? Early with threat modeling. and early with automated scans also. So all these automated scans, threat modeling, that and all ensures early adoption of security analysis. So that is what we call it as shift left principle. And next thing is continuous integration and testing, because many codes are being done parallelly, and many code modules are supposed to be integrated so that to get a final version of that particular software. So when you are integrating, testing should also be done parallelly. So code scans using some sort of tools that has to be adopted parallelly, right? And dynamic testing, that should also be exhibited. That is also very, very important, right? And then automation throughout the pipeline. So as long as you incorporate some manual intervention in any of the software development lifecycle model, probably that will delay your process, right? That might prone to errors that might in turn come out with ineffective software, right? So what people suggest is, let us go for automation. You have the pipeline activities. Let all the pipeline activities be automated, right? So DevSecOps automates scans, compliances, and deployment security. Everything is being automated. And next thing is shift right principle. Once shift left is over, parallelly at the early stage itself, we started testing. But still, now software is complete. Right? Now let us go for shift right also. The complete software that can be tested using shift right principle. So meaning post deployment. Once your software has been deployed, now I can in the course of using that particular software, a new security threats might happen. That might happen during the client end also. After the deployment, the clients might face new security threats. So that has to be corrected, and that has to be security free, right? That is what the shift right principle that takes care of that aspects. And next thing is and one more important thing is that should be collaboration between teams. As I told you, there are many teams involved in the development process, right? Starting from developers, security team, operations team. Unless or other than there is some good cooperation among them, this DevSecOps might not work as expected. And finally, compliance as code. I told you there are so many regulatory bodies, right, upon which that has to be made compliance with the development. There are some policies with we have supposed to follow that, right? Then only that particular code might be a quality code or an effective code. Right? So all these things are supposed to be managed and maintained. And next thing is, what are the benefits? Right? We are talking about so many things about DevSecOps. Obviously, it has some value, right? Start from stronger security, yes, because we are following shift left principle, right? So early stage itself, we are incorporating security aspects. We are using automated tools, right, for all the scannings, compliances, and everything. So obviously, we will have a stronger security. Once you are doing everything in a parallel way, right? The release of your software is also going to be faster, because when earlier stage, when people use only shift right, the security team has to wait for availing the complete software. Once they got the complete software for deployment, then only the software, security team will take care of that, incorporating in ensuring security and all. But now since everything is being done at the early stage, probably faster release of your software is a better benefit. And I told you, that should be some great teamwork among the developers, security team, and the operation team. Right? Since all these team members are working in a coordinated way for the successful of that particular software, obviously there will be some greater teamwork. Since you got some faster release, right? cost saving is also like a side product kind of thing, right? So obviously you will get some effective cost saving and higher quality. Since you come out with strong security, you obviously get you a product in a higher quality way and scalable and flexible, right? So we are as the developers, and that is the actual a benefit of a DevOps itself, right? Since developers and operation team, they are going with the parallel, any sort of changes, any sort of upgradation, any new requirement, there is a connection between connectivity between operation team and the developers. So everything has been sorted then and there. And that's why scalability and flexibility is always a great benefit when it comes to DevSecOps. And finally, compliances, right? All the regulatory bodies, regulatory compliances has been followed. And as long as it has been followed, we understand what is the actual complaints with respect to developing this particular software. So it has been made easy. So these are the benefits of DevSecOps. And to have a nutshell, right, of how does this DevSecOps works, right? So basically, what we are going to do is we are going to implement this DevSecOps. Software team must first implement DevOps. That is like a very basic need. This DevOps and continuous integration are the basic things with which any sort of development that has to happen. Once this has been happening, then only this DevSecOps might play an important role. And how this works, right? So I told you, there should be some collaboration, there should be some automation, and there should be some continuous security process throughout the software development life cycle. That is important. We should not start our security aspect at certain stage. It should be throughout. And finally, we have to monitor, right, all the possible visibilities into the application behavior, how this application behaves, everything that has to be taken care, right? And next thing is, this I think I already told you regarding the benefits, right? So it helps the organization, reduces the security risk by addressing the vulnerability early in the development process. And because of that, it promotes faster and more efficient software development, right? And it obviously improves the overall quality of the software. Just because we are continuously security testing has been done and monitoring has been happened. And of course, it encourages the culture of shared responsibility. I told you, collaboration, collaborative work has been happening. And that in turn creates a shared responsibility that in turn promotes the organizational culture, right? So that is very important. And okay, again, I think this has been covered, right? And now, how to use this particular DevOps? Right? Just like that, we cannot kickstart, right? So we have to educate your developers about what is the impact of secure coding. What are the practices that we have to follow for secure coding, right? And we have to provide them the necessary tools and training to identify and address the security issues. This is very, very important. With respect to the developers' perspective, all these sort of education has to be given. Then only the developers can incorporate security aspects at the early stage. Because unless or other they know the impact of security, how come they incorporate that into their development process, right? And next thing is, with respect to the operation team, right? So now operation team are the one, those who take care of continuous integration and continuous development process, right? So integration, security testing into the CI and CD, continuous integration, continuous development pipeline, and make use of the vulnerability scanning and code analysis tools to catch security flaws early on. So ultimate objective is to identify the security issues or the flaws at the early level itself. And okay, so these are the basic culture that DevOps, DevSecOps is expected to follow, right? So they integrate security into the software lifecycle. They are uniting the development, operations, and security team for collaborative and secure application delivery. So continuous security should be there, automation should be there, collaboration should be there, and of course feedback loop, because based upon the feedback only the next level of continuous security aspect that can be carried out. So okay, and that is what I explained. And one more important thing is, what are the things that have been involved in this particular DevSecOps culture? So basically, communication, people, technology, and process. All four things are combined together that formulates a DevSecOps culture, right? So communication in the sense, as I told you, like these companies, like they try to implement this particular DevSecOps, right? They want to promote, right? The ultimate aim is to adopt the security practices, right? So the senior leaders, right, they have to ensure, or they have to train and give the importance and benefits of security practices that has to be adopted, right, to the DevOps team. Then only they can realize the impact, and they start cultivating that during their practice. So software developers and operation team requires the right tool, right system, and encouragement to adopt DevSecOps practices. So communication is very, very important. And when it comes to people, right, we talk much more on this. The developers and operation team has to work closely. Okay. And next thing is technology. We are talking about automation. So technology gives you automation, right? Faster security testing rates, right? And speed delivery, right? Everything has been getting involved in that, right? And process, right? So when it comes to process is concerned, right? Basically, security testing and evaluation should happen at every stages of development. That is the actual process that we are expecting to carry out in the life cycle phases. So software developers check for security flaws when they are writing the code. It's a parallel process. And what is the difference between this DevSecOps and Agile development? Right? So obviously they are not mutually exclusive. Somehow or the other, there is a coordinated thing that some sort of similarities has been there. Basically, what happens is Agile allows the software team to act quickly on change requests. Meanwhile, DevSecOps introduces security practices into each iterative cycle in the Agile development. Agile development takes care of the quick developments. Right? This DevSecOps in the quick development, security practices are also incorporated. That is the only difference here. So I think we are already covered, right? Shift left, early development stage itself, we have to ensure security. Shift right, at the end of the software development, during the deployment phase, we have to ensure the software security. We have to include automated software security tools, and we have to promote security awareness. So that is what I explained in this particular thing. Now, to have a different dimension, let us go for some simple use case. And this use case is a realistic use case that has been taken from the Accenture company, right? So what we are going to discuss in this particular thing is, before DevSecOps that has been incorporated by Accenture company, what is the impact? How they develop? After incorporating DevSecOps, what is the impact? So that is what we are going to look into this particular use case, right? So this everybody knows. Accenture is a MNC company which operates 120 plus countries. And the specialization is IT services, consulting and operations. They focus on technology-driven solutions, right? And it is scalable with respect to millions of users and globally, right? More like complex IT operations or solved, and that has been incorporated in organization. That is what Accenture is taking care of, right? Now, what are the problems and challenges faced by Accenture? One thing is right? Security, right? Throughout, right? All the phases, right? And isolated operations, one after another, right? Security tool is different for design. Security tool is different for code analysis, right? So it is an isolated operation, and they are using some manual processes because only DevSecOps uses automated. They are using manual processes, and they are also went for limited agility because still they believed in traditional software development of a phased manner. They started incorporating the agility, but still not in a full-fledged way, right? And just immediately they cannot change which has been traditionally followed into a new thing, right? And there is a barrier with respect to the cultural changes that are supposed to be incorporated. So based upon all these problems and challenges, right, what this particular Accenture done is they try to incorporate or introduce this DevSecOps, right? Obviously, the purpose is they need speed and secure, and they want end-to-end automation, and they want to improve their collaboration, and they want to transform everything to cloud, and they have to enhance the quality of a particular software, right? In order to achieve all these things, they decided to introduce DevSecOps. Now, I told you what before DevSecOps that has been introduced, right? Before DevSecOps, teams worked independently. They got so much of bottlenecks, right? And the delivery, that is the time to market is slowed down. That is the greatest issue. And when it comes to security practices, security checks were introduced late in the development. Even Accenture done that, right? In such a case, that obviously leads to reworking and delayed delivery. Okay, and manual efforts are being more dependent, right? Since it is not been automated, manual efforts are more needed. Okay, and mindset when it comes to the team focusing on individual goal rather than a holistic service delivery. Because in DevSecOps, only the security team, development team, and the operation team are working in a collaborative way. Before that, there is no such thing, and every individual team focus on individual contribution, meaning they are worried only about their development. Operation team is only worried about their operations. And security team, once the code is developed, they will be worried only about their security testing level of that particular software. So that is how things be. And before this, the usage of DevSecOps in Accenture, what they have done is they were using the traditional continuous integration and continuous development tools. They have been using because monitoring tools are readily available even before DevSecOps. But that all are the old tools traditionally that has been used, right? And the normal shift right principle. In the end of the software development, people evaluate the security, right? So that is what the security testing that has been carried out before DevSecOps. Now, one DevSecOps that has been operated, one that DevSecOps has been integrated in the development process in Accenture, right? Some new tools that have been used, right, with respect to DevSecOps. That is, when it comes to continuous integration, continuous development pipeline, right? The tools like Jenkins, I think these tools have, we talked during the development process itself in the DevOps. All the tools, whatever we discussed, right? That and all are very important tools for automation, right? And infrastructure as code. There is no what we call it as a random assorted way in which code has been developed. The code has been developed with some structure, right? And people started using security tools, right, for automation and for continuous security scans, right? And there are some cloud native tools also. That is what our first session, right? Cloud native development, right? They started building tools that was cloud native. And fifth thing is we have to monitor and observe, right? There are so many proactive monitoring tools that has been there. Using those, this monitoring and observability have been taken care. And finally, we are talking about collaboration, development, security, and deployment. But there should be a platform that has to collaborate all three, right? So that is very, very important, right? How do they communicate? Right? That needs a platform. So this DevSecOps tool, DevSecOps gives you the collaboration platform like the Slack and Jira that improves the communication and tracking among the teams, in the sense operation teams, development team, and security. Okay. And what might be the results? Right? When the Accenture started using this DevSecOps security operation, what are the results are? Whatever we already discussed, like faster delivery, improved security, higher quality, enhanced collaboration, increased innovation, and operational agility. All these things favors this Accenture company, right? And finally, to summarize with respect to the case study, Accenture's DevSecOps journey embedded security. They automated the workflows and they boosted the collaboration, and they are able to enable the faster delivery, secure delivery, and efficient IT delivery, and that too globally. So that is an impact of using DevSecOps, right? And this is the pipeline normally this DevSecOps follow, right? So we have phases in DevOps, right? Plan, code, build, test, release, and deploy, right? So when it comes to this particular DevSecOps, what we'll be doing at what stage, right? During planning, right? Security analysis has to be done. We have to prepare a security test plan also. During coding, right? We have GitHub controls. Right? During building the particular thing, we have to ensure whether the code coverage has been done. For that, static testing. We already come across some testing, right? Static testing. That has to be ensured. And during integration testing, right? Because we are integrating and coming out with one single what software, right? For that, we have to go for dynamic testing. And that is what that DAST is all about. We already talked about SAST and DAST at the tool level itself, right? And when it comes to penetration testing, we have to take care of acceptance level testing. That testing has to be accommodated to ensure the security. Okay. And this is what been explained in this particular thing. All what we have supposed to do during planning, coding, building, testing, right? So I told you SAST, that is nothing but static application security testing, right? So that actually uncovers the problems in code before pushing it to the next stage. Because because wrong code, unsecured code, going for the next stage, of course that is of useless, right? Again, there will be security issues, and that being covered by this SAST. And this DAST is all about dynamic application security testing. I told you this dynamic application security testing has to be done with the third man's perspective. What hackers will do, right? So we voluntarily try, check for authentication and authorization, right? We try to break the system. I have to ensure whether this particular system, safeguards from breaking. Right? I have to inject error voluntarily, and my system should detect that particular error, and that has to be diffused. So that and all has been done by this dynamic application security testing, right? And what we have to do during release, right? We should use a security analysis tool, right, to ensure penetration testing. And after deploying, right? So we have to send a secure build to production, meaning upgradations, right? New versions of security models that might safeguard the deployed software. We have to ensure that. Okay. And what is the important consideration in building a pipeline? Number one, security scanners for containers, right? Like probably by this time, like you might have come across this containers in your early sessions. So that containers are supposed to be scanned for security aspect. And pre-commit hooks and security plugins. Excuse me. So normally, when it comes to testing the security aspect, we cannot write a separate code. So it should be like a drag and drop, or it should be a plugin aspect. When I incorporate the security plugin, it will be tested, and it will be evaluated and validated, and it showcases the issues. The issues can be rectified. And then we have to automate this continuous integration security testing also. Right? So because DevOps is all about CI and CD. So that has to be automated, both CI and CD. Right? And SAST that has to be done. And we have to manage the dependencies, because all working in a collaborative way. Obviously, there might be a need for dependency that has to be managed. And finally, we have to ensure the complete monitoring of the activities involved in the pipeline. Starting with all these things, right? So plan, code, build, test, release, deploy, all the been activities in the pipeline. Every pipeline activity has to be monitored. Okay, so that is the important consideration. And now we are talking about security, right? And one more important thing with respect to security is the resilience, right? Resilience in the sense, even right, if there is any sort of security threat that has been happening, right, the software has to withhold, and it need not go to the bad phase, right? Thing is, the only reliable way to ensure the software is constructed secure and resilient is by integrating a security and resilience mindset and process throughout the entire software development lifecycle. So what we are going to come across is, what are the security threats in every phases of SDLC, because this is very, very important. Unless or rather than we know all these things, how can we automate it? How can we analyze the scanning? How can I go across this security modeling, right? So these are the activities or threats or security aspects that has to be taken care in every individual software development life cycles, right? To start with, right? Let me go for it. When it comes to the requirement and requirement gathering and analysis, right? The foremost goals are going to be confidentiality and privacy. This has to be preserved, and integrity has to be preserved. Availability has to be ensured, and non-repudiation that has to be taken care. On auditing, regular auditing, that should also be done. So when it comes to the requirement phase, right? Probably what will be the key inputs is what the organization requires. Right? So organization might require the functionalities, right, for the software. That should be taken. And what are the privacy requirements that has been expected with respect to the organization? What are the statutory requirements that has been expected? And what are the industry requirements? Because please understand, organizational requirement is different from industry requirement. Right? Your organization might require something, but it might be completely different with respect to what IT industry requires. So what we are supposed to do is, we have to map the security and privacy requirement. Based upon that, the outcome or the key deliveries are going to be prioritize the security and privacy requirements. We have to frame it, right? We have to come out with some prioritize the security, right? And when we already discussed this, outcome of this particular analysis are going to act as an input for the next phase that is called design. So we should also ensure the key security related design goals, because once it has been ensured, that has to be accommodated in the design phase. So this is very, very important. So when it comes to the design is concerned, like we have to focus on the system design and the detailed design. Both things are different, right? But of course, these two things has to be taken care. And one more important thing is, when we decided to go for threat modeling, right? There are 4 steps that has to be taken care. Number 1, functional decomposition, because you got a big module. That particular module has to be functionally segregated, segmented. That is what decomposition is all about. Once functional decomposition has been done, now I have to categorize the threats that might, right, functionally attack the module. Now, once categorization has been taken care, I have to rank those threats. Because based upon the ranking of threats only, we can prioritize which threat has to be given more importance for removing that particular threat. So that has to be done. Once all the ranking and all has been taken care, mitigation planning has to be done. Mitigation is that transfers. I'm shifting from the unsafe zone to safe zone, right? So mitigation plan that has to be taken care. And every individual steps has been expanded here, right? It's a functional decomposition. What is, we are going to decompose the functionalities. It might be a big functionality. Let the functionality has been cut down into micro functionalities, right? When we will be using all these things is when the service can be, a service might be a great module, right? When the service has been cut down to microservices, even microservices is the functionality. Okay, so we have to decompose the functionalities. And when we would like to categorize the threats, we have a framework called STRIDE. Right? We have to understand this particular STRIDE categorization so that to build automated security code. Right? STRIDE stands for S for spoofing, T for tampering, R for repudiation, I for information disclosure, D for denial of service, and E for elevation of privileges. All put together we call it as STRIDE. So based upon there are different threats for a particular system, right? Now this threat comes under what category? Is that the spoofing thing? Or this particular threat is trying to tamper your data? Or it is spoiling the reputation of that particular system? Or it will disclose any information from the system? Or it is preventing from doing services for other legal operations? Or it is elevation the privileges? So based upon threat, we can understand which category this threat belongs to. Right? So when it comes to STRIDE, as I told you, these are the abbreviations. When it comes to spoofing, spoofing is illegal accessing and then using another user's authentication information. Right? Say changing the authorization, if you change the photograph in an ID card, that is spoofing. Right? So when you go and approach a particular person using a fake email ID that seems like the original, that is what spoofing is all about, right? Tampering obviously is a modification of data, right? If you do some modification and in turn that causes a serious damage, that is what we call it as tampering. One small digit that has been tampered that causes a great damage for a particular company, right? This is what unauthorized changes made to persistent data, such as that held in a database, and the alteration of data as it flows between two computers over an open network, such as the because obviously when tampering happens, when you transfer data from one network to another network, one system to another system, right, via internet. right? Obviously, there is a scope for unauthorized people to tamper your data. Okay, and repudiation. Threats here are associated with users who deny performing an action without other parties having any way to prove otherwise. Meaning, say for example, when a user performs an illegal operation in a system, right? And that's very difficult to trace it. Very difficult to trace it, right? Just because of the repudiation of that particular person. The user, right? Non-repudiation refers to the ability of the system to counter the repudiation threats, right? Say for example, a user who purchases an item might have to sign for the item upon receipt. That ensures the a simple security, right? The vendor can then use the signed receipt as evidence that the user did receive the package, because the package has been received for delivery. But how do I ensure this particular package belongs to the authorized person? That and all takes care in the repudiation process. And information disclosure, right? So exposure of information, sometimes leakage of data. It might happen deliberately or sometimes unknowingly also. Denial of service. More services given for a particular computer. Already that particular computer is serving some services, right? What you're going to do is you want that particular service to be stopped. If you that particular service has to be stopped, this particular process, right, needs more work. When more services are given for a particular process, it cannot do so much of services and it will start denial a particular service. Right? That is what denial of service is all about. And alienation of privileges. Right? Say, as I told you, the attacker will effectively penetrate all system defenses and become part of the trusted system. Right? Earlier he was an unauthorized person. Now, based upon his experience and hacking nature, he started behaving as an authorized person. Unauthorized person in an authorized way is very dangerous. Okay. And once you categorize, you understand about threats, I mean the strike threats, you have to rank it, right? Because you have to prioritize it, right? So how ranking is going to be taken care? Based upon 5 factors. Those 5 factors we call it as threat, right? So D stand for damage potential, meaning you got a threat, you got a issue. How great it will damage your system, right? What is the damage potential? Sometimes when you use pen drive, right? So normally a virus might get into that. Some viruses are harmless, but some viruses are greatly monitors our system and damage our system. So we have to understand the damage potential, how this can create a damage for the system. And reproducibility, right? How easy is to reproduce that attack? Because when it comes to reproduce, the developer, the hacker might also reproduce the attack. With respect to the user also reproduce the attack just because to learn what this particular attack is all about. Okay. And exploitability. How easy is to launch an attack? Right? So when you create a trust, right? Obviously people don't doubt you. Probably can go and exploit that particular system. That also happens, right? Affected users, as a rough percentage, how many users are affected? Affected of what? Affected based upon this particular threat. This threat is there, the security issues are there. They started scanning the existing code using the old thing. Now I want to ensure, right? How much what user that has been affected just because of this particular threat. And discoverability, how easy to find the vulnerability. This is important, right? If you are able to crack the vulnerabilities at the easy stage, that will be good enough. So we should be in such a way that, right, it should be easy to find the vulnerability factor. And next thing is mitigation planning. With the list of ranked threats, you can document a high-level mitigation plan by mapping them to a potential vulnerabilities in the software system. So mitigation is all about conversions or transfers, right? So here, right, the mapping of potential vulnerability in the software system is being handled by this mitigation planning. And now, when we talk something about design phase, right? So obviously it will get the input from the previous phase, that is the requirement phase, right? Now we should understand the design principles. We should understand the flow of that particular design. We should also understand the technical and non-technical control requirements with respect to security. All these things are going to act as an input for the design phase, right? The design phase are going to take care of threat modeling and the security design review. Once this has been taken care, probably the expected output are going to be the key deliverables. So here, key deliverables are nothing but, right, the well-organized or categorized and ranking of threats. Just imagine, once we are able to categorize threat, once we are able to rank the threat, probably we understand the design. That is very important. And there should be some high level of mitigation plan, and you have to come out with the secured architecture and design also. So that is what we are expected to do in the design phase. So one, we have to model the threat, and number two, you have to design the security model. Okay. These are all are normal things. When it comes to static analysis, probably we have to find the bugs, we have to check the styles, we have to check the types, and we have to ensure or review the security vulnerability aspects. Okay. These all are not that bad things. Okay, basically we undergo unit testing and all, right? Because you have completed a module, you can go for unit testing. Now completely coming to the development phase, right? So obviously we will be getting the input from the design phase, right? We are supposed to develop source code in this particular phase, and we are supposed to develop the source code in a secure way, right? We have to ensure that also, right? Whether the configuration is being standard, whether you are able to do a unit test case, that and all are very important when it comes to development phases. Once all these key inputs have been handled, now we go for the key deliverables. Obviously, vulnerability, right? Vulnerability from automated analysis. That is the greatest deliverable. Also, vulnerabilities from peer reviewing and unit testing. So this is also an important key deliverables with respect to the design phase. I mean the with respect to development phase. Okay. And now the testing phase, right? So testing in the sense we can go ahead with security test. We can go ahead with prioritizing the list of vulnerabilities from the automated and manual dynamic analysis. Right? Because we completed the code. Right now we are testing it. Right? So when it comes to testing, you need some test cases. Right? So all these things will be taken care, and secure test case, that is very, very important. That's what given in this diagram. When you are testing, you have to test completely at the same time in a secure way, at the same time at the faster way. That is the motto of this particular thing, right? And of course, there will be some sort of dynamic analysis that has to be taken care by the testing team. Okay. And now finally deployment. Deployment in the sense delivery, right? And when it comes to delivery is concerned, final security review has been taken care, and application security monitoring and response plan is also taken care. Obviously, the key deliverables are going to be what? Security review, sign off, security monitoring, and the response plan. So these are the key deliveries that might happen right in the deployment phase, right? And we are almost at the end of our session. So now I'm going to compare finally with DevSecOps and DevOps in terms of some factors. Number one, the focus of DevOps are going to be only in the development with automation of CI and CD, continuous integration and continuous development. But when it comes to DevSecOps, security at every stage is going to be the focus, right? And with respect to security, DevOps, security is handled late in that particular pipeline, often as an afterthought, because that might not be an important thing with respect to the security. So they have been handled late, right? But when it comes to this DevSecOps, security is integrated early and automated throughout the life cycle. So we need not worry at all. It has been integrated, yes, and that has been also taken care of automated, right? So security is high in DevSecOps. And next thing is collaboration, right? It encourages full collaboration across software development, right? Developers. So already we come across developers, security, right? And operations team and so on. So, okay. And next thing is automation. Automates security check and monitoring at every stages of the process. Obviously, we are following a shift left principle, right? Okay, meaning early stage of testing and security. So if that is going to be the case, automated security checks and monitoring in every stage is the need of the hour. Okay. And risk management, obviously DevOps might not have much risk management, meaning it prioritizes speed and efficiency with the security risks often addressed by post deployment. So at this stage, that is not required also, right? And next thing is with respect to DevSecOps, it proactively identifies and mitigates security risks early in the life cycle, right? So that everything talks about early life cycle, right? And tools, right? We discussed the complete slide for tools, right? So it's when it comes to this DevSecOps tools, it has security tools like Sync, OWASP, and Forti for continuous security and the complaints. Okay. And with respect to the tools in DevOps, we are using the outdated tools called Jenkins, GitLab, Docker, and Kubernetes, right? All these things are being taken care by this particular thing. And finally, compliances, right? So DevOps compliance checks are often manual or conducted late in the process, right? So there's as security coming late, this compliance is also coming at the end. But when it comes to DevSecOps, right? Compliance as code in the sense early stage for continuous automated monitoring of standards like GDPR and HIPAA, right? So these are the compliances that have been made use by the DevSecOps. Okay. And to conclude, so we are talking so much on DevSecOps, but actually, if you see, that is not a methodology, meaning that is a mindset. When you ensure that, yes, I would like to incorporate, because person to person, the security aspects differs. Few people might be comfortable having the security at the end, shift right principle. Right? When you adopt in the shift left principle, it needs some cultural changes, right? And that's the reason DevSecOps is a mindset and not a methodology. And it bridges the gap between speed and security, obviously, right? Speed is also increased. I mean, I'm talking about the delivery, and it also ensures security also, right? And one important thing is the security is embedded in every phase of development, not exactly in the development of code, in the implementation phase. Security is also embedded in design phase. Security is also embedded in analysis phase also. And of course, it fosters collaboration among the teams. Three teams are getting involved here: operations team, security team, and development team. So unless there are collaboration, you can't get the secured software. And one more thing is this DevSecOps or making use of great tools, right? So that is also a great advantage. And finally, this particular DevSecOps, it tries to empower faster, safer, and more reliable software delivery. Of course, that is going to be the motto or outcome of any software that has been delivered or deployed, right? So these are the things that has been achieved by DevSecOps, right? So with that, I conclude my session. So thank you, one and all, for patient listening. And I think I covered DevOps, and today it's all about incorporating security in DevOps, its impact, the tools involved in that, the advantages and benefits, what is the culture that has been followed, that has to be done, what are the activities in the pipeline, right? And then we come across a simple case study of Accenture before DevSecOps that has been incorporated in Accenture, and after incorporating in Accenture. And we discussed about security aspects in every stages of software development life cycle, start from analysis, design, implementation, and testing. And we discussed their impact. And we have something called stride, that is categorization of threats. And once categorization of threats has been done, we have to rank the threat, rank the what we call the threat. Then only we can understand and prioritize the threat impact. Based upon that, we can automate the sport scanning or any other security tools, right? So with that, I once again thank the organizers for giving me an opportunity to come back again to deliver this particular session. And I also thank the audience, because it's almost 9 o'clock, and people who are online and listening, definitely you should need some sort of patience and some passion towards learning. So in that way, I'm happy and thankful to you all. So thank you, one and all.
Thank you, sir, for your enlightening and thought-provoking session. We are grateful for the time to effort you took to share your expertise with us. Thank you, sir.
Okay, thank you, one and all, and see you all later. Thank you.
Thank you, sir.
Okay, thank you, Balaji. Thank you.
Thank you, sir.
Thank you, ma. Thank you.
Thank you all for your attention. And looking forward to welcome you all tomorrow with the same cooperation. Thank you all. Thank you.
Algo Good evening, all. It's just a reminder that tomorrow's session will commence at 2 p.m. and it will be continuing till 6:30 p.m. We will be continuing with the assessment and validatory function. Your active participation is highly valued, and I look forward to seeing you all tomorrow. I request all the participants to join the session by tomorrow 2 p.m. sharply. Thank you all.
Dear participants, tomorrow we have three sessions and also assessment session is there, the final round. And after the assessment, we have to conclude all the sessions and validate function. So I request all the participants to attend all the sessions.
Assessment time will be 6:30 to 7:30.